Stabilizing Global Temperature. By Clive Maitlas. Email clivemaitlas@gmail.com. If you notice any errors, or have suggestions for improvement, just send me an email, and the amendments will be put into the next edition. If you will read this book with an open mind, you may well see climate change from a perspective that is new to you. You will wonder why it has not been resolved decades ago. The scientific knowledge and the technical means are readily available. It is just that the political will is lacking. Available as a printed book and an ebook. Table of Contents. Executive Summary. Recommendations. The absurdity of net zero measures. Climate complexity. Tipping points and feedback terminology. Context. Temperature anomaly. Sulfur emissions man-made. Sulfur emissions natural. Sulfur is an essential part of natural cycles. Carbon dioxide in the atmosphere. Heat radiation from Earth. What is carbon dioxide good for? Crop yield increase and starvation reduction. Simulating the temperature anomaly. How does the greenhouse effect vary with CO2 concentration? What if sulfur emissions had not been curbed? What can we do? We must urgently implement climate restoration. Sea level rise. What is the optimum CO2 level? Carbon capture and storage. Solar geoengineering, a key component of climate restoration. Minimal human health implications of solar geoengineering. Would solar geoengineering reduce photosynthesis? A seriously problematic unwitting solar geoengineering experiment. The quadruple whammy harms from cutting sulfur from ship fuel and aviation fuel. The astonishingly low cost of solar geoengineering. Calculation of transport fuel economy. The astonishingly high cost of net zero carbon dioxide. Marine cloud brightening. Really caring for the environment. The moral case for private action. The mandatory nature of moral action. What can concerned enthusiasts do? How high is the stratosphere exactly? Are carbon credit schemes a massive fraud? Cooling credits versus carbon credits. Who is opposing solar geoengineering, and why? A mental health pandemic, worrying about the climate. Closing comments. Appendix, averting the next ice age. Chapter, Executive Summary. Global temperature is rising. The temperature rise trend is undoubtedly at least partly due to human activity. Measures to reduce greenhouse gases, CO2, methane etc., are not likely to happen quickly. Not quickly enough to stabilize the temperature before tipping points are reached. The cost of decarbonizing the economy is extremely high. Net zero CO2 emissions is an important goal, but is unlikely to happen for several decades on an optimistic timescale. Even if net zero were reached, global temperature would continue to rise, due to the existing excess of greenhouse gases already stored in the atmosphere and dissolved in the oceans. Long before net zero is reached, we may reach various positive feedback tipping points. Beyond these points, temperature rise is likely to accelerate, with diminishing hope of controlling it. This is extremely serious. It is urgent. Net zero is far too slow to respond. Global temperature rise has been rapid since around 1970. With a further increase in slope from around 2022, provisional data. Sulfur and other aerosols have a significant cooling effect. This is well known. And has been known for over 2 centuries. Volcanic emissions were recognized as causing cooling since the eruption of Tambora in 1815. The year without a summer. Since around 1970 there has been a significant slowing of sulfur emissions from human activity, essentially flat from 1970 to 1990, then reducing. Meanwhile CO2 emissions continued to increase. If human-sourced sulfur emissions had continued from 1970 as a straight line increase, there would be almost zero increase in global temperatures today. Or indeed a slight reduction. High concentrations of sulfur in the air is harmful to humans and to trees. However, the concentration needed to stabilize global temperature is very low. It is at least 2 orders of magnitude lower than would be harmful to human health, if applied in the stratosphere. Sulfur in the soil is a necessary nutrient for plant growth. Without it, plants are stunted and crop yields collapse. Since the desulfurization of coal-burning power stations, UK agricultural soil has become increasingly deficient in sulfur. Sulfur has to be added, or crop yields are impacted. Sulfur in the sea is a necessary nutrient for algae, phytoplankton, seaweed, kelp etc. These account for around a third of all CO2 uptake and half of all oxygen production. There has been a dramatic reduction of phytoplankton and kelp in recent decades, which appears to be correlated with the reduction in human emissions of atmospheric sulfur. Correlation does not imply causation. This is an area requiring further analysis. There may be multiple factors behind these reductions of marine photosynthesizing organisms. But sulfur is a necessary nutrient for them. We need to urgently know whether sulfur must be reintroduced into the marine environment. Other factors affect algae and phytoplankton. Some areas of ocean are depleted in iron. An experiment to add iron to these areas resulted in a significant increase in algae and phytoplankton, and consequent very significant increase in fish numbers. Despite being clearly beneficial, further experiments were banned by the Canadian government. Ocean fertilization with iron could be a highly effective means to draw down CO2, at relatively low expense. Ocean fertilization has the potential to sequester gigatons of CO2 per year. My suggestion is to use iron sulfate, thus addressing the iron deficiency and the sulfur deficiency simultaneously. It is commonly used as a lawn fertilizer. If there is a reduced drawdown of CO2 by marine organisms such as algae and phytoplankton, it is likely that the excess CO2 will remain in the atmosphere, hence contributing even more to global temperature rise. Plant growth is significantly enhanced by increased atmospheric CO2. Commercial greenhouses increase the CO2 up to 2000 ppm, which is about 5 times the current atmospheric concentration. And this 2000 ppm is about what it was when plants first evolved. Plants require less water as the CO2 increases, resulting in the greening of vast areas of semi-arid regions. If an efficient method of CO2 removal was implemented, and CO2 reduced to pre-industrial concentrations, there would be a sharp reduction in crop yields, and an associated food shortage crisis, and mass starvation on a vast scale never before experienced. Thus, CO2 reduction should only be done at a pace corresponding to the natural reduction of the human population, via humane means such as birth control, in order to avoid hardship and mass starvation. For the next few decades the human population is projected to continue growing, before leveling off. Global temperatures thus need to be stabilized, then reduced by around 1.5 degrees Celsius, without dramatically reducing atmospheric CO2. There seems to be only one method that is technically easy, economically viable, and immediately implementable: deliberately add sulfur and other cooling aerosols to the atmosphere. Above tropical oceans would have the greatest overall cooling effect. If the sulfur could be emitted far from humans and trees, high in the atmosphere and out above the oceans, then the benefit of its cooling could be obtained, whilst minimizing impact on human health. The concentration needed is very low anyway, much lower than you would notice by your sense of smell. Since the removal of sulfur from ship fuel since 2020, there has been a step increase in sea surface temperature. At low altitude, temperature is well over 100 times more sensitive to sulfur than to CO2. In the stratosphere, temperature is 5 or 6 orders of magnitude more sensitive. Before the removal of sulfur, ships' emissions were providing twice as much cooling as heating. The late Professor Stephen Salter investigated the use of fine salt mist dispensed from ships. This results in marine cloud brightening, due to cloud formation. Clouds cannot form without nucleation particles such as dust or salt. The air over oceans is very clean, and so clouds are less likely to form. The reflectivity of clouds is much higher than cloudless oceans. It could be done at relatively low cost, Professor Salter calculated that a fleet of drone vessels spraying salt mist to entirely halt global warming would cost less per year than one COP conference. He calculated that several years ago, and since then the number of attendees has shot up, in 2023 nearly 84,000. Could they not do COP via Zoom instead? Chapter: Recommendations. Achievable nearly immediately, we must urgently implement solar radiation management, SRM. One highly effective method is by deliberately adding sulfur to aviation fuel and to marine fuel. With preferably 2 grades of marine fuel, low sulfur for use in ports and near populated areas, and high added sulfur for use far from populated areas. The concentration of sulfur in the air reduces rapidly with increasing distance from ships. It would be straightforward to manage a vanishingly small impact on human health. Solar geoengineering/SRM is a well-established concept. The sensitivity of global temperature to sulfur at high altitude, the stratosphere, is 5 or 6 orders of magnitude higher than to CO2. At low altitude, temperature is around 2 orders of magnitude more sensitive to sulfur than to CO2. Prior to banning sulfur from ship fuel in 2020, they were providing about twice as much cooling due to their sulfur emissions than heating due to their CO2 emissions. There may be some remaining arguments regarding the exact figures of temperature sensitivity to sulfur vs CO2, but such arguments cannot be an excuse for procrastination. We can refine the figures as we go. Also achievable in a very short timescale, weeks or at most a couple of months, convert surplus fighter jets to dispense sulfur dioxide at high altitude. The Royal Air Force is soon to retire some 30 Typhoon jets. These could be repurposed to carry around 7 tons of hydrogen sulfide to 60,000 plus foot. When combusted in the jet pipe of the engines, this becomes sulfur dioxide. And the quantities required are astonishingly small. 1 sortie per day would cancel out the entire global warming contribution of the UK greenhouse gas emissions. Around 90 sorties per day would cancel the heating of entire world emissions of greenhouse gases. This is entirely achievable, and at an astonishingly small cost. Of course, it would be preferable if every major country were to fly 1 or 2 surplus military jets of comparable performance, and not concentrate all the sulfur over the UK alone. In context, there are around 90,000 commercial aircraft flights per day. Achievable within a few years' timescale, marine cloud brightening using salt water mist. The equipment can be fitted to existing ships. And to fill in gaps of coverage, in areas away from shipping routes, a fleet of drone boats can be deployed. A very fine mist of salt water is sprayed into the air. The droplets are carried by air currents to a few thousand feet altitude. The salt particles form nucleation points onto which larger drops of water condense to form a cloud. The air over oceans is typically very clean. The air may be moist enough to form clouds, but without nucleation points, clouds will not form. Clouds are far more reflective than a cloudless ocean, reflecting a significant proportion of solar radiation back into space. Whereas ocean water absorbs sunlight which then warms it up. The late Professor Stephen Salter calculated the annual cost to stabilize temperature globally by marine cloud brightening, MCB, is less than the cost of a COP conference. That was calculated several years ago, when the number of delegates was half their recent number. And yes, MCB would change rainfall patterns, but, except in a very few areas, there would be more rainfall in currently arid areas. Overall, it is highly beneficial. The resulting change of albedo can be monitored by satellites in nearly real time, and so if problems were to arise, the spraying of salt mist could be halted, or moved to other locations. There will not be one single approach that is needed to stabilize global temperature, but multiple in combination. It is painfully obvious that CO2 emissions will not be stabilized in any realistic time frame. And may not be desirable to do so too rapidly anyway, without risking significant crop yield reduction and hence starvation on a previously unknown scale. We do urgently therefore need to deploy solar radiation management at large scale, and as quickly as possible. And do so before various irreversible tipping points are reached. Within a very short time frame, oil refineries can stop removing sulfur from aviation fuel, and also some grades of ship fuel, and can do so economically. This will buy us some time, as we develop equipment for marine cloud brightening via saltwater spraying, to be fitted to existing ships, and to drone boats. We do not need to give up hope. It is all eminently achievable. Chapter: The Absurdity of Net Zero Measures. You maybe have heard of net zero. In a nutshell, someone who pollutes, maybe by flying in their private jet to a COP climate conference, can offset their CO2 emissions by paying for carbon credits. And this despite the fact that a significant number of carbon credits funded projects are of questionable value to the climate, and in some cases are blatantly fraudulent. Some carbon credits projects are producing more heating than cooling. The effect of useless carbon credits is that even more CO2 is emitted than would be otherwise the case if such useless things did not exist. For the simple reason that the people who purchase these useless credits thereby feel free to continue emitting CO2. But it is worse than them merely wasting their money on something useless. There is the opportunity cost too, that money would have been far better spent on something that actually has a chance of working to stabilize global temperature, namely, cooling credits. It is the temperature rise that is the primary concern. Stabilizing the temperature and then gradually reducing it should be the primary goal. The goal should not in itself be trying to manage this or that particular gas concentration in the atmosphere. Do you see the important distinction? Cooling credits would pay for solar radiation management in its various forms, including putting aerosols such as sulfur dioxide into the stratosphere, and by spraying a fine mist of salt water over oceans marine cloud brightening, and by other means, such as painting roofs with special white cooling paint, etc. etc. These deployments can be monitored in near real time by satellites, and their efficacy measured nearly straight away. Cooling credit payments would be based entirely on proven/demonstrable efficacy, and would be far more honest and immediate than bogus carbon credits, which resemble a massive scam in some cases. Cooling credits are quite unlike many of the useless/marginally useful carbon credits projects. For example, tree planting takes decades for the trees to grow to any significant size, and who knows how many will grow and how many die. Or whether someone will chop them down, years after the landowner has been paid his carbon credits money. In other words, the claims regarding how much carbon the trees will sequester can be wildly inaccurate. There is a significant social aspect to net zero too. Those who propose it must dream up ever more draconian measures, limiting personal freedoms, in order to foist their unworkable schemes onto an unwilling public. The public really is not stupid. They know, almost instinctively, when some public policy is going badly wrong. The public maybe does not know all of the details, and this is why the experts have their way, at least for a time, until the downsides become ever more apparent. Remember that the experts were pushing thalidomide pharmaceuticals, which resulted in many thousands of babies being born with physical deformities. Fortunately, some were skeptical of the claims and refused to take thalidomide, including my own mother. I am grateful that she resisted the insistence of her doctor, or I would have been a victim. The instincts she had were of greater truthfulness than the opinion of the expert. One of the climate experts who is desperately pushing net zero policy is Professor Miles Allen of Gresham College. Here he is discussing it. YouTube: A just and inclusive net zero, who should get there first? Miles Allen. The video has not had very many viewings, but nevertheless it is significant. Because this mode of thinking is being pushed into the UK government. I do not know why I become quite so disturbed by all of this, but nevertheless here is my comment below the video. This fixation on net zero is puzzling and somewhat disturbing. It is not going to happen anytime soon. Face facts. Even if it miraculously happened tomorrow, that would merely slow down the rate of increase of temperature, because of all the greenhouse gases already in surplus in the atmosphere and dissolved in the oceans. There is only one way to stop the temperature rise: solar radiation management. I know you despise it. But this is the reality now. It is far from ideal, but it is the least bad option right now. It is eminently affordable, and can be quickly deployed using existing technology that just needs minor adjustment to repurpose it. And please stop with the termination shock bull tea scaremongering. Or at least be honest and consistent, and use that same argument to oppose carbon capture and storage. But why no scaremongering against CCS? Maybe because it is not scalable, and even if it were, it is impractical purely based on energy balance. We have to get real. This is the only planet that is habitable. And get real before the various tipping points are reached. And no, I am not funded by oil companies, before all the ad hominem attacks start. Ad hominem attacks indicate that you have run out of rational arguments. I am not sure why exactly I feel so annoyed and frustrated. Maybe it is because I can see that intelligent people such as Professor Allen, who have not really thought things through, pushing for something that they must know is not working and is unlikely to work in any sort of useful timescale. And even if net zero were miraculously achieved, the temperature would continue upwards for decades longer, due to the huge inertia in the climate system. While disparaging an approach, solar radiation management, which would quite rapidly solve the temperature rise crisis. And do so at an affordable cost, with really very minimal adverse effects. Chapter: Climate Complexity. The climate is complicated. It takes a significant amount of time and effort to get to grips with what is really happening. Computer simulation models that have attempted to predict the future global temperatures have often been wrong, which implies that some factors are not properly understood. More accurate accounting of the cooling effect of sulfur and other aerosols is urgently needed. Aerosol masking of underlying temperature driving has been increasingly noted, since 2020. Paper published by Nature, Aerosol Demasking Enhances Climate Warming over South Asia. This book has been written by someone trying to get to grips with the climate issue, to discover whether carbon dioxide is as serious a problem as we are led to believe. It is not written by a climate denier, nor by an eco-alarmist. And certainly not in the pay of the fossil fuel industry. I would be a lot wealthier if that were so. And would probably be in the denier camp. But I am just someone who is curious about the topic, and wants to see for himself what really is happening. And whether we should be panicking or not. And who should we believe? We must weigh the costs of CO2, increased heating, with the benefits, greatly increased crop yields, and so lifting billions of people out of starvation and poverty. I constructed a spreadsheet. It only factors in two contributions to atmospheric temperature, carbon dioxide and sulfur dioxide. There are of course many other factors, but these are the main ones that humans have significant direct control over. CO2 is a greenhouse gas, and SO2 is an anti-greenhouse gas. It cools the planet, directly by reflection of sunlight, and indirectly by seeding clouds. In the spreadsheet, for the years from 1850 up to nearly the current date, these gas concentrations are multiplied by adjustable scaling factors, simulating their impact on atmospheric temperature. The temperature contributions of CO2 and SO2 are then added together. The scaling factors are adjusted until the calculated temperature graph fits well to the actual measured temperature graph. The starting year 1850 was chosen, because it is prior to the massive growth in industrialization. Also, it is not easy to get data for SO2 emissions from human sources prior to that date. Ideally we would do a best fit graph to the past 1000 years, but going back to 1850 seems adequate for an initial examination. But considering the temperature contribution of gases is not straightforward. Causes and effects are nonlinear. Doubling CO2 does not double its contribution to the greenhouse effect. An analogy: if you put two duvets on your bed, you do not get twice as warm as having just one. There is a law of diminishing returns. In other words, the use of a single scaling factor in a simple multiplication calculation is not adequate to describe what is happening. A nonlinear scaling factor must be applied. This is what has been done in the spreadsheet. It then gives a pretty good correspondence between simulated temperature and actual temperature. We can always add more details, but just getting the outline understanding is a vital first step. An added factor is the natural occurrence of SO2 in the atmosphere. Volcanic activity produces SO2, and this absolutely has to be included in the calculation. Per ton, SO2 is several orders of magnitude more effective at reducing global temperature than CO2 increases it. At low altitude it cools by about 2 orders of magnitude more than CO2 warms. At stratospheric altitude it cools by 5 or 6 orders of magnitude more than CO2 warms. It is very curious that all the policy emphasis is on reducing CO2 alone. I think I have identified why. By pure coincidence, man-made sulfur dropped rapidly at the same time that there was a large increase in volcanic activity in 1991, thus masking the huge sensitivity to sulfur. However, since the inadvertent geoengineering experiment that mainly began in 2020 with the banning of sulfur from ship fuel, this masking effect has become painfully evident. A note to the pedantic: I have generally used the term sulfur to describe all sulfur compounds. Maybe the term sulfate or sulfite is pedantically more accurate. But the problem with using one specific form of sulfur name is that it then is too specific and so excludes other forms. It is possible to be pedantic and wrong. Chapter: Tipping Points and Feedback Terminology. The terminology around climate change can be a little confusing. When climatologists discuss positive feedback, is this indicating a good thing or a bad thing? When we are chatting with friends, positive feedback is a good thing. It helps us to understand one another better and to resolve misunderstandings and conflicts. Whereas negative feedback in that context would be unhelpful. However, this same terminology when applied to the climate is quite the opposite. A positive feedback system is not good, it is divergent. So, for example, a positive feedback loop in the climate would mean that an increase in temperature creates conditions that make temperatures increase at an even faster rate. Whereas a negative feedback system reduces divergence, and leads to a more stable system. If you think of your heating thermostat, it measures the temperature in your room, and switches off the heater when the room gets above a set temperature. This is negative feedback. And is a good behavior. Your room stabilizes at a comfortable temperature. If your thermostat develops a fault, and instead of switching off the heater above a set temperature, it were to switch it on, this is positive feedback, and not what you want. An already hot room would become even hotter. There are climate systems that do have a positive feedback behavior, typically after a certain temperature is reached. That is called a tipping point, and takes us into a rapidly worsening situation. One example of this would be the melting of permafrost, which would release a vast volume of methane that is currently trapped in the ice. And methane is a potent greenhouse gas. So raising temperature even more, and so melting more permafrost, which then releases even more methane. And so on, in a positive feedback loop. To avoid this, it is urgently necessary to stabilize global temperature. And this must be done right now, without further delays. One way to do so is solar radiation management. Hoping to achieve net zero CO2 emissions anytime soon is almost certainly not realistic. Even with huge effort and expense, it is not realistic. We have to face facts now. And even if net zero were achieved immediately, which is not possible, the temperature would continue rising for years or decades, due to the CO2 that already exists in the atmosphere and oceans. And due to the start of triggering of the methane tipping point, and the ocean circulation tipping point, and several others too. Chapter: Context. The climate has always changed dramatically, and this was happening long before humans became numerous and developed fossil fuel burning technology. For context, we should look at the longer timescale of the last few ice ages, stretching back over 400,000 years. Here are the ice core temperature measurements taken at the Vostok Research Station. It uses deuterium measurements as a proxy of temperature. This graph of ice core temperatures goes backwards in time, i.e. the more recent time is on the left of the graph, and progressively older measurements are to the right. Scale: thousands of years before present. The graph shows the temperature variation relative to present-day temperature, at the Vostok Research Station in Antarctica, near to the South Pole. The measurements go back nearly 450,000 years. In that time, there were 4 glacial periods, ice ages, and 5 interglacial warmer periods. These cycles occur entirely naturally, with no human intervention at all. We are currently in an interglacial period. Within this current period, 8,135 years ago, the temperature has been plus 2 degrees C above the current temperature. In the previous interglacial, 128,500 years ago, it has been more than plus 3 degrees C above current temperature. The glacial ice ages last considerably longer than the interglacials, and go down to minus 9 degrees Celsius relative to current temperatures. Note to the pedantic, yes, we are technically in an ice age now, because there is ice at the poles. Polar bears evolved around 400,000 years ago from brown bears. They have survived through multiple temperature cycles of plus 3 degrees C to minus 9 degrees Celsius and back. Therefore, I don't think we should worry about their survival, if temperatures alone are the concern. Pollution is a separate concern, that should be addressed, of course. Pollutants, including substances in the water that mimic female hormones, should be a concern for all species, including for humans. Chapter: Temperature Anomaly. The baseline date is 1950. Temperatures are relative to the temperature at that date. This data is freely available for download from the Berkeley Earth website. The data was put into a spreadsheet in order to produce this graph, and also as the reference to fit a best-fit graph of simulated temperature changes. Chapter: Sulfur Emissions Man-made. Industrial processes have resulted in the emission of sulfurous gases into the atmosphere, predominantly sulfur dioxide. SO2 acts to cool the atmosphere directly, and also indirectly by seeding cloud formation. Since the 1970s, efforts have been made to reduce sulfur emissions. By removing it from transport fuels, and by scrubbing it from the flue gases of coal power stations. It peaked at around 130,000 gigagrams, which is 130 million tons. By comparison, CO2 emitted in 1970 was 15,000 million tons, so 115 times more CO2 than sulfur. Note well, from around 1940 to 1970 there was essentially zero change in temperature trend, if you average out the wobble, and during this time the man-made sulfur emissions increased in lockstep with man-made CO2 emissions. There thus seems to be a natural ratio that results in no net change in temperature. That ratio presumably being about what it was when the coal and oil was laid down long ago. Although in the case of coal, part of the sulfur seems to have been taken up from mainly the soil when the trees were alive, and part leached in later after the trees dies. Nevertheless, trees today have a far lower sulfur content than the trees that later formed coal seams. It is logical, that if we want to maintain a steady temperature, we try to recreate that natural ratio that existed long before humans existed. Whatever the actual figure was, it seems probable that it was significantly higher than today. In high concentrations sulfur is not good for us, it results in breathing difficulties. In excessive concentrations it is also not good for the environment, acid rain is harmful for trees. The man-made emissions of SO2 slowed from around 1970, and reached a plateau. It has generally declined from that peak. Look at the SO2 graph and also the temperature anomaly graph. The horizontal axes are approximately on the same scale. Curiously, or not, this sharp leveling off and subsequent cut in SO2 emissions has corresponded with the noticeable increase in global temperature. This is not at all a coincidence, it appears to have a causal link. To be discussed further. Source: Anthropogenic sulfur dioxide emissions, 1850-2005. Chapter: Sulfur emissions natural. Volcanic activity produces considerable quantities of sulfurous gases. An initial spreadsheet calculation of temperatures was performed, using just the man-made CO2 and man-made SO2 figures. However, it proved to be impossible to get a good fit between the calculated temperature anomaly curve and the measured temperature anomalies curve for data prior to around the year 1940. A much better fit between these curves was obtained when natural SO2 emissions was included in the calculation. Unfortunately, there does not seem to be a data set of natural SO2 emissions stretching back to 1850. However, we can calculate an approximate figure, based on volumes of volcanic eruptions. The buildup of SO2 in the atmosphere does not happen instantaneously that the volcano starts erupting, and it remains in the atmosphere for some time after it ceases erupting. In order to take this time factor into account, a rising slope, attack, and a falling slope, decay, are calculated. Note that the y-axis is in arbitrary units. But this is not such a problem for the overall calculation, because a scaling factor is applied, and adjusted in order to best fit the observed temperature curve. We can certainly find this simplified data to be useful, as it quite well explains much of the temperature variations prior to 1940. The major volcanic eruptions, together with their volume of material ejected, are listed on Wikipedia. Year. Name. Volume, km3. 1800. Mount St. Helens. 1.5. 1815. Mount Tambora. 190. 1822. Mount Galunggung. 2. 1835. Cossagana. 4.25. 1843. Mount Agung. 1. 1854. Shivaluj. 2. 1875. Askja. 1.83. 1883. Krakatoa. 26. 1886. Mount Taraira. 2. 1902. Santa Mara. 20. 1907. Kasaduk. 1.75. 1912. Novarupta. 31.2. 1924. Submarine volcano north-northeast of Iriamat Island. 1. 1932. Quizapa. 9.5. 1933. Karamkotan. 1. 1955. Bezimiani. 1.9. 1963. Mount Agung. 1. 1980. Mount St. Helens. 1.3. 1982. El Chicha. 2. 1991. Mount Hudson. 4.3. 1991. Mount Pinatubo. 13. 2011. Puyahu Cordacol. 1. 2022. Hunga Tonga Hunga Ha'apai. 9.5. Chapter, Sulfur is an essential part of natural cycles. Sulfur is essential for life to exist. The natural sulfur cycle existed long before humans came into existence. Sulfur cycles through the atmosphere and oceans, and rainfall, and soil. On the way, it forms essential biochemical components of living organisms. It is essential for the life of plants, animals, microorganisms, insects, fungi, etc. In too high a concentration, yes, it is harmful to health, causing breathing difficulties. But it is to be welcomed at low concentrations. It fertilizes the soil, the rivers, and the sea. This really is all that needs to be stated, to challenge the assumption that chemicals such as sulfur are automatically bad. They are not. In appropriate concentrations they are essential for the health and well-being of the whole of life on our planet. Restore sulfur, as part of climate restoration. Since the desulfurization of coal-burning power stations, UK agricultural soil has become increasingly deficient in sulfur. Sulfur has to be added, or crop yields are significantly impacted. Article on the Scottish Farmer website, lack of sulfur in 97% of UK soils. You maybe eat sulfur eggs, dairy, onions, etc. Sulfur is a key part of ecosystem balance. Chapter: Carbon dioxide in the atmosphere. The measurements of CO2 needs to be on a consistent basis. The data used here is from ice core measurements. Thus avoiding arguments about how to combine measurements from different sources and measuring stations. And avoiding concerns about the measurement stations being adjacent to volcanoes, etc. The warming effect of each molecule of CO2 declines as its concentration increases. Putting 2 duvets on your bed does not double your temperature. See the section below. How does the greenhouse effect vary with CO2 concentration? Chapter: Heat radiation from Earth. CO2 is a greenhouse gas. That is, it attenuates longer wave radiation, heat, from leaving Earth. How much does the greenhouse effect change if CO2 were doubled to 800 ppm? Small. Barely visible on a graph. It is around 3 watts per square meter. See this article for details. The greenhouse effect, a summary of Wijen, Arden and Happer. They have calculated the climate temperature sensitivity to a doubling of CO2. Note that they have only considered clear sky radiation, and did not include the effects of cloud cover. Cloud cover increases the reflectivity of the planet, and is therefore a cooling effect, so these figures indicate that 2.3 C rise is the maximum possible temperature rise as a result of doubling CO2. But with the caveat, it does not include tipping points, which act as positive feedbacks of temperature. Chapter: What is carbon dioxide good for? CO2 is consumed by plants. Without it, they cannot grow. If they are not limited by other factors, soil fertility and water, the higher the CO2 level, the larger and healthier the plants will grow. In fact, plants growing in an atmosphere of increased CO2 do not need as much water. The consequence of increasing atmospheric CO2 has been an increase in crop yields and a huge increase in the plant cover in semi-arid regions. Commercial greenhouses deliberately elevate CO2 levels to around 5 times that of atmospheric concentration. Plants first evolved at a time when atmospheric CO2 was far higher than today. 500 million years ago CO2 was up to 9,000 ppm. Plants in our current atmosphere are relatively stunted. Experiments have been done that show the dramatic increase in growth of plants, as the CO2 concentration is increased. Below 200 ppm the rice plants are severely stunted, see the photo. It should be no surprise that agricultural crop yields have increased significantly over the last few decades as the CO2 concentration increased, resulting in less poverty and starvation around the world. As plants are stressed, for example by having restricted water, the difference in growth between those with enhanced CO2 and those with atmospheric concentration is even more dramatic, in a good way. See this article, CO2 enrichment and plant nutrition. Chapter: Crop yield increase and starvation reduction. Can you imagine how terrible it must be to experience famine? Not just experiencing your own hunger, but to see your child withering and dying in front of your eyes, and knowing that you can do nothing to prevent it. We must have empathy for those in such a terrible situation. There has been a nearly doubling of crop yields, tons per hectare, since 1960. And a very significant reduction in starvation percentages over that time period too. In developing countries, undernourishment has reduced from 35% to 13%. This is a truly remarkable achievement. Of course still far too high, but it is going in the right direction. Crop yield increases are partly driven by improvements in agricultural practices, artificial nitrate fertilizer etc., but surely some positive credit must also be given to increasing temperatures, and hence increasing rainfall, due to more evaporation from warmer oceans, and increasing CO2. Increasing temperatures result in a longer growing season in temperate areas. Increasing temperatures also produce more evaporation from oceans and hence produce increasing rainfall, which of course is absolutely necessary for agriculture. Increasing CO2 results in faster and larger growth of plants everywhere. In semi-arid areas plants grow better with an increased CO2 level, because the pores in their leaves do not need to open as long, and hence they lose less water from the leaves. And this is particularly a factor in areas where water is scarce, lifting people out of starvation and poverty in marginal lands. There has been an astonishing increase in plant leaf area, across nearly the whole globe. Chapter: Simulating the Temperature Anomaly. The measured temperature anomaly data has been downloaded from the Berkeley Earth website. It has been loaded into a spreadsheet, together with the CO2 and man-made SO2 emissions data, and volcanic emissions too, and a curve-fitting calculation performed. The result is shown here. It is quite a good fit but not perfect, because only CO2 and SO2 have been considered. There are numerous other factors that would ideally be included too: solar radiation variation, tilt and changing distance of the Earth to the Sun, Milankovitch cycles, cosmic ray variation. They also seed the cloud formation and hence change the albedo. See the book The Chilling Stars, Methane, Ozone, Water Vapor, Weather Cycles, Nitrous Oxide, Particulates, etc. etc. Has someone done a detailed model to simulate all of these? Did they see how significant the man-made SO2 emissions are? In particular the dire effect on temperature of cutting SO2 emissions from 1970 onwards. If they did see it, why are they keeping quiet about it? It should be front-page news. Chapter: How does the greenhouse effect vary with CO2 concentration? Atmospheric CO2 concentration is currently a little over 400 ppm, parts per million. But what if it doubled to 800 ppm? How much would the greenhouse effect change by? Would it double? No, it certainly would not double. As worked out in the spreadsheet, by using curve fitting between the simulated and actual temperature anomaly curves, it was found that the greenhouse effect has already gone significantly nonlinear with respect to CO2 concentration. However, the spreadsheet calculation overall is simplified compared to the full picture. It does not take into account numerous factors, as noted earlier. So this nonlinear curve should be regarded as an initial result only, and needs to be refined if a more accurate relationship between CO2 concentration and greenhouse warming needs to be known. Fortunately, others have already done this calculation. Quote, doubling CO2 increases the greenhouse effect by 2 watts/m2 out of 240 watts/m2, i.e. less than 1%. See CO2 saturation effect. The effect is not quite logarithmic, but is fairly close to being logarithmic. Is the saturation of CO2 logarithmic? See Beer-Lambert law article on Wikipedia. It seems highly improbable that CO2 levels would get anywhere near 800 ppm. However, because if temperatures do rise, then the growing season would be extended in higher latitude areas, with a considerable increase in the absorption of CO2 by plants. Also, plants are a long way from reaching saturation in their ability to absorb CO2. Therefore, there is a powerful negative feedback, self-regulating mechanism operating. Negative feedback is a good thing as it helps to stabilize a system. Chapter: What if sulfur emissions had not been curbed? This is a very interesting question. As noted earlier, sulfur emissions man-made, efforts were made to limit and reduce SO2 emissions, and these efforts have been very effective from around 1970. However, CO2 continued to rise, and so the overall effect from around that date is of a rising temperature trend. Here is the simulation of temperature anomaly for a straight line increasing SO2 after 1970, if sulfur emissions had not been curbed. Conclusion: if we had allowed the SO2 to rise after 1970 as a straight line extrapolation of its rise from 1950 to 1970, then we have an interesting result. There would have been zero rise in temperature, or indeed a slight reduction. Additionally, if William Happer is correct, that temperature is relatively insensitive to CO2, then it further highlights just how sensitive global temperatures are to SO2. Sulfur is still fairly linearly affecting temperature, as it has extremely low concentration 0.035 ppm in UK cities. It is lower than you can smell, and far below toxicity limits. CO2 is significantly nonlinear at its current level 420 ppm. Ratio is 12,000:1 CO2 sulfur. It should be no surprise therefore that the air temperature is far more sensitive to changes in sulfur compared to changes in CO2. Sulfur is a key part of all living beings. The atmosphere needs it to be in balance with CO2, for climate restoration. Bring back sulfur, all is forgiven. Chapter: What can we do? We must urgently implement climate restoration. Well, it should be obvious, rather than hoping to get global CO2 emissions down to zero, accept that this is an impossible task, at least in the near term of the next few decades. Reductions should be realistic. If global warming really is the catastrophe that the environmentalists claim it to be, then urgent drastic action is called for. The simplest approach, economically and technologically, is to ramp up the release of SO2 into the atmosphere. Now, as noted earlier, this does have disadvantages at high concentrations, causing breathing difficulties and acid rain. However, if the SO2 could be released where it would be most effective, high in the atmosphere, and as far away as possible from people and animals out at sea, then it might just be a workable solution. The required concentrations to stabilize temperature are very low, well below any toxicity limit, and well below the smell threshold. Here is the suggestion: continue to remove sulfur from fuel for road and rail transport. But put an increased amount into aviation fuel and ship fuel. Ships could use low sulfur fuel in ports, switching to lower cost, sulfur-enriched fuel when more than 20 miles from the leeward shore. Aircraft also have multiple fuel tanks. Sulfur-enriched aviation fuel could be used once cruising altitude is reached. Particularly useful for long-haul flights and for the flights over oceans. Oceans absorb more sunlight than land. Seeding clouds there has a greater effect on temperature than over land. This release at high altitude is far more effective than at ground level, and so less sulfur would be needed overall. At altitude it helps to seed cloud formations, and thus reflects even more sunlight back out to space, for a combined powerful cooling effect. Significantly reducing the sunlight being absorbed by land and oceans, the albedo of clouds is significantly different. The SO2 would be predominantly concentrated high up, above the clouds. Below the clouds it soon washes out by rainfall, leaving hardly any at ground level. How about it? We must reduce our use of oil and gas, primarily to stop funding theocratic countries that have appalling human rights records. They use the oil wealth to fund the spread of their evil ideology worldwide, and seem to have blackmailed Western governments to stay silent, and suppress dissent. Existing renewable energy sources have limitations: dark winters with no wind, just when more electricity is needed. Yet there is a huge resource of predictable tidal flow energy that is largely untapped. And micro-hydro turbines, although individually small, when added up the UK has river flow energy equivalent to a nuclear power station with an estimated 20,000 to 30,000 disused mill sites in the UK. Chapter: Sea level rise. Sea levels are currently rising by around 3 mm per year, and have naturally risen since the end of the last glaciation, by about 120 meters. Projections do vary, but best estimate is 0.6 meter rise by 2100. Is this something to be worried about? No, certainly not. Simply stop building new structures within X meters height of the maximum astronomical high tide, where X is a function of the expected lifespan of the structure. A wooden beach hut erected 0.3 meter above high tide level is not a concern. If it is inundated after 40 years, it is likely to have reached the end of its life anyway by then. A more permanent structure, made of brick, concrete, or steel, expected to last 100 years, should be erected no lower than say 1.5 meters above highest astronomical tide. The sea does not rise instantaneously, and there is ample time for coastal populations to adapt. The land area lost to the sea would include arable land. However, its loss is dwarfed by the massive increase in the agricultural productivity of enormous areas of land at higher latitudes. and by the rapid greening of semi-arid areas by increased CO2 fertilization. So, really, stop worrying about sea level rise. Have a sense of perspective, and preserve your mental health. Chapter: What is the optimum CO2 level? This is the real question that needs to be answered. It is absurd that environmentalists want CO2 to be reduced to pre-industrial levels. Immense harm would be perpetrated if that was done. Hundreds of millions of people would starve as crop yields crash. Questions about how much more the population of polar bears will increase by, yes, their numbers are increasing significantly, as temperatures increase, or by how many millimeters per year the sea level will rise by, are very much of secondary significance. As atmospheric CO2 increases, and temperatures rise and hence rainfall increases, due to increased evaporation, there is a tremendous increase in crop yields, and a reduction in starvation. However, if CO2 levels would be reduced at a rate quicker than the rate of reduction in human population, by humane, gradual means such as birth control, then hundreds of millions of people, or maybe billions more people would be brought into starvation conditions. Is this what the environmentalists want? Most regions of the world are projected to have a stable/declining population from around 2050. So, if we are of a humanitarian mindset, we should not be significantly reducing CO2 emissions before that date. Plants evolved at a time when CO2 levels were far higher than they are currently. C. Stomatal control as a driver of plant evolution. The vertical bends are origination of A. Planate leaf, B. Ferns, C. Cycads and Ginkgoaceae, D. Conifers, E. Angiosperms, F. Grasses, and G. C4 grasses. Note that grasses with the C4 photosynthetic pathway are more efficient at absorbing CO2 compared to C3 photosynthesis, which is most plants. It makes sense that C4 evolved when there had been a significant reduction of atmospheric CO2. Around 540 million years ago the CO2 level was around 6,000 ppm, at the time the early plants gained significance. CO2 reduced to around 3,000 ppm around 400 million years ago when vascular plants evolved. As more plant species evolved, around 300 million years ago, the CO2 dropped to 500 ppm, and meanwhile oxygen rose to 32%. From around 250 million years ago to 100 million years ago CO2 levels fluctuated around 1000 ppm. From around 50 million years ago the CO2 levels have been at unprecedentedly small values of below 400 ppm, and, without the intervention of human activity over the last couple of centuries, the decline of CO2 levels was on a trajectory that would be calamitous for the survival of plant life, and hence all life. We really need to be grateful for CO2. At current levels, plants are well below their optimum. Technically, we are in an ice age now, because there is ice at the poles. Plants thrive when the global temperature is warmer than present, and when CO2 levels are much higher than present. And if plants thrive then animals thrive too. Directly or indirectly animals, including humans, take sustenance from plants. Commercial greenhouses increase CO2 levels up to 2000 ppm. At 1000 ppm photosynthesis increases by a huge 50%, see the article, Supplemental Carbon Dioxide in Greenhouses. Humans can breathe with CO2 levels far higher than the current concentration. Health and Safety Executive UK permits up to 5000 ppm for an 8-hour period, general hazards of carbon dioxide. Incidentally, do you know why there has been no coal formation for the last 300 million years? It is very interesting, look it up. And see how, up to that time the CO2 levels, blue line, had plateaued to about 500 ppm, before shooting up to about 1500 ppm when coal formation stopped. Chapter: Carbon Capture and Storage. Carbon Capture and Storage, CCS, seeks to capture carbon from sources such as fossil fuel power stations, or directly from the atmosphere, and store it in an inert form, locking it up for a long duration, millions of years. The initial motivation for doing the spreadsheet was to quantify the demand for CCS. However, a rather more significant realization was made, that the benefits of increasing CO2 for humanity and for the ecosystem more generally, since less land would be needed for agriculture if crop yields are high, compared to marginal productivity, far outweigh the drawbacks. Then realizing that the environmentalists who strongly influence the governments who would control this CCS process simply cannot be trusted to set the atmospheric CO2 to a rational level. They would set it to pre-industrialization levels, which would severely impact crop yields, and so result in mass worldwide starvation, at a severity never before witnessed. CO2 does need to be stabilized, but not reduced at a rate that exceeds the natural rate of reduction of the human population through humane means such as birth control. Not through inhumane means such as mass starvation and warfare. If rising temperatures are the primary concern of the environmentalists, rather than directly CO2 itself, then temperatures can relatively easily, and by technically feasible and relatively cost-effectively achieved by controlled emissions of SO2 into the atmosphere, well away from populated areas. And most effectively at high altitudes over the oceans. The oceans absorb more sunlight than land, and so reducing the power of sunlight reaching the oceans would most effectively reduce overall global temperatures. Local conditions may require other patterns of cooling, however, and there is significant scope for further scientific research. But avoid analysis paralysis. Get on with initial trials, quantifying the impact, and iteratively improving the effectiveness. Energetically, CCS may be questionable, unless there is an abundance of energy that cannot otherwise be used. For example, solar panels on the Sahara could provide low-cost electricity for CCS. The Sahara is too far from population centers for electricity to be economically transmitted, but it does have virtually uninterrupted sunlight, and the land is not usable for other purposes. Australia has large desert areas too, and benefits from political stability relative to countries bordering the Sahara. Chapter: Solar Geoengineering, a key component of climate restoration. Some people simply are averse to any sort of technological development. They hark back to some sort of fictional bucolic Garden of Eden world prior to the Industrial Revolution and its dark satanic mills. The reality, of course, is that for many, before the benefits of modern technology, including medicine, that life was quite brutal and short. Those who deny the benefits of progress seem to have a lack of gratitude for the blessings that scientific and technological progress brings to them. We are custodians of this planet, and it is our duty to perform climate restoration. There are numerous possible approaches, as discussed here. Climate Restoration Roadmap 2024. The Climate Restoration Safety and Governance Board, Solar Geoengineering is a key component of climate restoration. Professor David Keith of Chicago University, and formerly Harvard, has for years been calling for a research program to investigate solar geoengineering/solar radiation management. Here he is describing it, on YouTube, Why We Should Research Solar Geoengineering. David Keith at Harvard College. CO2 emissions will be reducing naturally over the coming decades, simply because the remaining reserves of fossil fuels are becoming increasingly difficult and costly to extract. However, probably not at a rate that would stabilize the global temperatures quickly enough. Solar radiation management is a credible way to rapidly and relatively inexpensively bridge the gap over the coming few decades. It ideally involves spreading a low-concentration layer of aerosols such as sulfur, mostly sulfur dioxide, high up in the stratosphere, and preferably above the oceans. There is relatively little turbulence at that altitude. Chapter: Minimal Human Health Implications of Solar Geoengineering. If using sulfur for geoengineering/solar radiation management, we need to calculate whether the concentration in the atmosphere needed to stabilize global temperature would be below the threshold for human health and safety. The most likely type of gaseous molecule used is sulfur dioxide. Either directly emitted into the atmosphere from pressurized canisters, or far more conveniently as a component of combustion products of a sulfur-enriched hydrocarbon fuel. In the latter case, other combustion products such as sulfur trioxide would be produced, but nevertheless, sulfur dioxide would be the predominant product. According to the UK Health and Safety Executive, the upper limit of SO2 permissible in the workplace air is 0.5 ppm, parts per million, for an 8-hour exposure. In the atmosphere, the background level of SO2 is well below this figure. In most UK cities, SO2 levels are below 35 ppb, 0.035 ppm. Question: can we do solar geoengineering using a minimal increase in sulfur concentrations? Professor David Keith has done considerable research into solar geoengineering. I have contacted him by email and asked the question, do you yourself have an estimated/approximate figure for atmospheric sulfur concentration ppm, that would be needed to stabilize temperature? I appreciate that far more research is needed to give an exact figure. His reply: it's not about ppm, it's about aerosol size dist and loading. Suggest you start with a good meteorology text. He is of course correct, however I was hoping for a specific ppm value, in order to see if it exceeds health and safety limits for human health. Never mind, I will attempt a calculation myself. However, in two cases, one's case where the solar geoengineering is performed at low altitude. For example, by sulfur-enriched marine fuel. And the other case, where sulfur is emitted at high altitude, in the stratosphere. The following are my own calculations, not the professor's. You may wish to double-check my maths for accuracy. Calculation: for the case of solar geoengineering at low altitude using sulfur. Until 1970, the human emissions of sulfur relative to CO2 emissions was consistent with the natural concentration ratio of sulfur and carbon in fossil fuels. 1 part SO2 to 115 parts CO2. Predominantly emitted at low altitude. Until that date, global temperature was relatively stable. After that date, human emissions of sulfur were deliberately and considerably reduced relative to CO2 emissions, and no surprise therefore that global temperature rapidly increased, and still is increasing rapidly, 5 decades later. From the mid-1930s until 1991, natural sources of sulfur from volcanoes was at an unusually low level. The CO2 concentration in 1970 was 325 ppm. Divide 325 by 115 equals 2.8 ppm sulfur. The UK House limit for SO2 is 0.5 ppm, so this 2.8 ppm figure is 5.6 times higher than safely permissible. But if the emissions were done far out at sea, rather than near populated areas, then low-altitude geoengineering could play a part in providing global cooling. So we cannot use low-altitude sulfur emissions for the whole geoengineering task, for health and safety reasons. But it could be safely used for 1/5.6 equals 17.9% of the overall geoengineering task. The remaining approximate 82% must be done at high altitude. Calculation: for the case of solar geoengineering at high altitude using sulfur. 1 ton of sulfur spread in the stratosphere can counter the heating effect of an astonishing 152,000 tons of CO2. Combating climate change with sulfur. The current atmospheric CO2 level is 424 ppm, measured in May 2023. The required sulfur concentration in the stratosphere is thus 424/152,000 equals 0.0028 ppm, which is more than 2 orders of magnitude lower than the 0.5 ppm health and safety limit. There is virtually nobody at 60,000 feet altitude to breathe it anyway. And if they were, they would be quite unharmed by this exceedingly diluted quantity. Chapter: would solar geoengineering reduce photosynthesis? This is a good question. If it were to significantly block sunlight, to the extent that photosynthesis is significantly reduced, then we would be in extremely serious trouble. Because photosynthesis is sucking CO2 out of the air, and if it was impeded, then the atmospheric CO2 would increase at an even greater rate. We would be in a no-win situation. We need to examine this question carefully. We must firstly understand what plants need. They need sunlight, of course. But what part of sunlight precisely? Interestingly, they do not absorb the whole spectrum of sunlight, but just two specific wavelengths only, red, 662 nm, and blue, 430 nm. They do not absorb green, they reflect green. If they did absorb green too, then to our eyes, they would appear black. Our eyes are sensitive to red, green and blue, and insensitive to infrared and ultraviolet. Some flower petals reflect UV, and bees are also sensitive to UV, and so are attracted to these flowers. Isn't nature wonderful? To add to the complexity, there are two types of chlorophyll, type A and type B. Of these, the A type is the most significant. It is in plants and in algae. A and B operate on slightly different wavelengths, but still within the red and blue wave bands. The question now is, what is the absorption spectrum of the proposed solar geoengineering particles or molecules? Do they have significant attenuation of red and blue light, or do they attenuate primarily at other wavelengths? Here is the absorption spectrum of sulfur dioxide, top trace, and comparison with sulfur trioxide, middle trace, and water vapor, bottom trace. Note that the x-axis units are micrometers. To convert to nanometers, multiply by 1000. Note that sulfur dioxide primarily absorbs at far infrared wavelengths, and not at the visible blue and red wavelengths that chlorophyll need. Sulfur dioxide does also have some absorption at UV wavelengths, around 300 nm. Not shown in this graph. But that is well away from the blue and red wavelengths of chlorophyll. Conclusion: placing sulfur dioxide into the stratosphere will not at all adversely affect the ability of plants to absorb sunlight at the chlorophyll absorption wavelengths. If hydrogen sulfide is combusted in air, it primarily produces sulfur dioxide, but also a smaller amount of sulfur trioxide. The trioxide also absorbs primarily in the far infrared wavelengths, and so is not a problem for plant growth either. Sulfur dioxide will also not adversely affect solar panel efficiency. The panels use the visible spectrum only, not the UV or IR wavelengths that SO2 absorbs. Chapter: A seriously problematic unwitting solar geoengineering experiment. We are already doing a solar geoengineering experiment involving sulfur. Unfortunately, in exactly the wrong direction. The International Maritime Organization has been very successful at removing sulfur from ship fuel, which has therefore reduced the cooling over the ocean. Starting in 2015 and more widespread from 2020 onwards, they have reduced sulfur in fuel from typically 4.5% to well below 0.5%. The result is observable by satellite measurements. There is around 3 West per square meter increase in Indiana's solar absorption over the North Atlantic and North Pacific, the main shipping routes, as a result of cutting sulfur from marine fuel. In context, doubling CO2 would increase solar energy absorption of the Earth by 2.28 W per square meter. 3 W is significantly greater than 2.28 W. See this YouTube video at 10 minutes. Global warming in the pipeline and Earth's energy imbalance. Quote: since the strong regulations on ships went into effect in 2020, solar radiation absorbed by Earth has increased about 3 watts per meter squared in the North Pacific and North Atlantic. On global average, the solar radiation absorbed by Earth has increased about 1 watt per meter squared. This increase of absorbed solar radiation is the reason that Earth's energy imbalance has almost doubled since 2015. Global warming will accelerate. Cutting sulfur is equivalent to 20 years' increase of greenhouse gases. Dr. James Hansen, a prominent climatologist. As he quite rightly points out, this is a big F-king deal. With such a large boost in solar absorption as a result of cutting sulfur from fuels, it is going to be impossible to limit temperature rise to 1.5 degrees Celsius, and probably not 2 degrees Celsius, even with large cuts in CO2. Almost certainly as a direct consequence of cutting sulfur from marine fuel, 2023 has had the hottest sea surface temperature on record, with a step increase compared to the previous hottest year. And February 2024 is hotter even than August 2023, the peak of that year. And yes, the El Niño cyclic variation in the Pacific Ocean partially adds to the temperature rise, but cannot explain just how large the rise is on this cycle. Extremely concerning. And yet this is with a steady increase in CO2 on the same trend line as previous years, not a step increase in CO2. So why the step increase in sea temperature? Yes, maybe other factors are in play, but surely the banning of sulfur in marine fuels must be examined as a significant factor. El Niño temperature fluctuation with CO2 rise does not alone account for such a dramatic increase in such a short time, so there must be a significant additional factor such as cutting sulfur. At sea level 1 ton of sulfur has the cooling effect to cancel 115 tons of CO2 heating. The suspicion is that banning sulfur in marine fuel was done without any careful consideration at all of its effect on temperature. This discussion is really nailing the scope of the problem, on YouTube 2023, plus 1.54 degrees C. Why is global warming accelerating? Interview with Leon Simons. Here is the paper being discussed, Global Warming in the Pipeline. Earth's energy imbalance has been severely impacted by the actions of the International Maritime Organization. With immediate effect, the sulfur must be added back into marine fuel. And if technically possible, even increase the percentage to above 4.5% sulfur. Hydrogen sulfide has a high solubility in oil, and so it would not be a technically difficult implementation. At sea level, the cooling effect of 5% sulfur in marine fuel produces a cooling effect 2.2 times higher than the warming effect of the CO2 it produces. Calculation: 5% divided by 100/115% divided by 2.6 equals 2.2 times. And 10% sulfur fuel would be 4.4 times more cooling than warming. Ships have multiple fuel tanks. It is easy to fill some tanks with low sulfur fuel, for use in port and near populated areas, and others with sulfur-enhanced fuel for use say 20 miles from land. An extremely serious error has been made by cutting sulfur from marine fuel. It is urgent to reverse this error. What if we overdo the cooling due to aerosols, including sulfur? This is not going to happen, because it would be relatively quick and easy to stop adding aerosols. If there was a very large natural emission of sulfur, from a large volcano Krakatoa or Tambora, the man-made sulfur emissions could be halted very rapidly. The Mount Pinatubo volcano cooled the planet by 0.5 degrees Celsius for a year. Deliberate man-made cooling could be reduced or paused for a time, until the cooling effects of such a volcano abated. What is the sensitivity? The cooling effect is very sensitive to relatively small quantities of sulfur, in fact astonishingly sensitive. 1 ton of sulfur spread in the stratosphere can counter the heating effect of an astonishing 152,000 tons of CO2. Combating Climate Change with Sulfur. Professor David Keith of Chicago University, and formerly at Harvard, puts the figure at 1 ton sulfur offsetting 1 million tons of CO2. What's the right temperature for the Earth? And practical geoengineering. However, I will use the 152,000 figure in my calculations, but bear in mind that this may be an underestimate, by a large factor. We need to urgently reverse the mistake of removing sulfur from ship fuel. And reverse the mistake of removing it from aviation fuel too. By removing sulfur from marine fuel and aviation fuel, we are already doing solar geoengineering, but in the wrong direction. Therefore, those who are opposed to geoengineering are probably doing so from an aesthetic viewpoint, with an underlying hatred of technology and a hatred of chemicals, rather than from a rational evaluation of the facts. Chapter: The quadruple whammy harms from cutting sulfur from ship fuel and aviation fuel. Here are some of the impacts of cutting sulfur. 1. Sulfur itself reflects sunlight. The reduction in sulfur has increased the radiant flux from the sun absorbed at the surface. And this is particularly a problem with ship emissions. The ocean is significantly more absorptive of radiation than the land. 2. There is a reduction of cloud formation. Clouds also reflect sunlight, and so more sunlight is absorbed by oceans and land. 3. Some species of phytoplankton and algae produce dimethyl sulfide, DMS. DMS is a potent cooler of the planet. DMS comes out of solution from seawater and rises in the atmosphere. It is only slightly soluble in water, and so remains in the atmosphere for longer than more soluble sulfur compounds such as sulfur dioxide, which is highly soluble in water. SO2 is quickly washed out of the air by rain. With less sulfur from ships in particular, there is less sulfur being washed into the oceans, and hence less DMS being produced by plankton and algae. I speculate that this reduction of DMS production took a year or so to become serious, and may account for the 2-year time lag between cutting sulfur from ship fuel, and the very significant increase in radiant flux and so increase in sea surface temperature, particularly in the North Atlantic and North Pacific, where there are many ships. If so, as sulfur in seawater becomes even more depleted in future years, this will limit the growth of plankton and algae. They will then, not only produce very little DMS, giving cooling, there will be a reduction in the capacity of oceans to absorb CO2. Significantly too, they are sensitive to increasing acidity, so the productivity of DMS will drop even more. And hence the greenhouse heating will really take off as CO2 builds up at a far more rapid rate. Phytoplankton and algae account for 45%, 50% of global CO2 absorption. If their absorption rate is reduced because of a shortage of sulfur, then we can expect a dramatic step increase in atmospheric CO2, even if human emissions were to be stabilized. DMS concentrations are projected to reduce significantly, see the paper, Changes in Global DMS Production Driven by Increased CO2 Levels and Its Impact on Radiative Forcing. For a lack of sulfur in soil results in reduced crop yield. There is a severe depletion in the UK soil, as a result of sulfur emissions cuts. For those countries that can afford it, they will import food from elsewhere, which inevitably leads to increased food miles and hence increased CO2 emissions. And of course leads to food shortages in countries that cannot afford the inflated prices. Lack of sulfur in 97% of UK soils. Sulfur, a vital nutrient optimizing productivity and crop quality on both arable and grassland farms, is fast becoming increasingly important, and new forms of sulfur fertilizer are gaining popularity. Professor Steve McGrath, head of Sustainable Agricultural Sciences at Rothamsted Research, told delegates to a conference at Grantham that sulfur was an essential element for all plants and animals to make essential amino acids. Cutting sulfur emissions has been done with the best of intentions. And in some cases where the emissions are near to people, and in high concentrations, it is entirely rational to do so. However, such decisions seem to have been taken with no consideration at all to the unintended consequences. There seems to be an irrational hatred of chemicals. But this fails to acknowledge that all living things are made of chemicals. There needs urgently to be a review of emissions, with the aim to restore the natural balance that nature and agriculture desperately needs. Chapter: The Astonishingly Low Cost of Solar Geoengineering. If someone were to pay you £10 million for putting 2 tons of sulfur into the stratosphere, could you do it? Maybe you yourself could not do it, but with a significant budget such as this, then you could soon find those who can do it. Maybe using high-altitude balloons, or high-flying aircraft. Or a large gun such as the 16-inch gun of Project HARP. It fired shells of around half a ton to altitudes around 400,000 feet, with the potential to fire every half hour, 24 tons per day. There is a trade-off between payload and height. More payload is deliverable to a lower height. Alternatively, a rocket/ramjet combination could be used. The Bloodhound missile could reach 70,000 feet. But without the need for a radar, and Mach 2 speed is not a requirement, we could envisage something similar going to a significantly higher altitude, or the same altitude with larger payload. The fuel for the ramjet could be H2S. The rocket for takeoff, and thereafter the ramjet burning the H2S in air, to produce SO2 and H2O. It would be recoverable by parachute or by landing on a runway, and reusable many times. How high is the stratosphere? It is around 11 kilometers, 36,000 feet, to 50 kilometers, 164,000 feet. The higher the better. Passenger planes tend to cruise at around 40,000 feet. Some business jets can reach 50,000 feet. The B-52 bomber can also fly to 50,000 feet. And do so carrying a heavy load 142 tons of fuel plus 31 tons payload, which could be a tank of hydrogen sulfide. If the fuel was 5% sulfur, that would be 7.1 tons of sulfur. Allowing 1 ton for the H2S tank and burner, so 30 tons of H2S could be carried. But H2S is 94.1% sulfur by weight, so 30 tons H2S equates to 28.2 tons of sulfur. The tonnage of sulfur delivered to the stratosphere in one sortie would be 28.2 tons plus 7.1 tons equals 35.3 tons. However, some fuel is needed for getting up to altitude and returning, so let us say approximately 30 tons of sulfur. In a single sortie, thus cancelling out the warming effect of 30 x 152,000 equals 4.56 million tons of CO2. In context, humanity emits about 100 million tons of CO2 per day. UK emits 1.14 million tons per day. In other words, 100/4.56 equals 21.9, thus only 22 B-52 sorties per day would be needed to cancel out the heating effects of the entire worldwide CO2 emissions. This may sound like a lot of sorties, but it really is small compared to the number of passenger plane flights per day, around 90,000. Alternatively, SO2 could be carried and sprayed directly without the need for a burner. However, it is inefficient to carry oxygen as part of a molecule, since it is freely available in the air. SO2 is only 50.04% sulfur by weight. H2S is far more efficient. If the burner is configured as a ramjet, it would also contribute to the thrust, and so potentially allowing a higher altitude to be reached. The scaled composites Proteus aircraft is designed for high-altitude flight. It has flown to 63,000 feet. It can carry a payload, which could be a tank of hydrogen sulfide. There could be an integrated burner, to produce sulfur dioxide. The burner, in the form of a ramjet, producing thrust and so enabling a higher altitude to be reached. Here is a photo. It is carrying a radar pod. It looks to be an easy task to install a tank of H2S instead. It had an empty weight of 2.7 tons and a max takeoff weight of 5.7 tons. It seems that it could therefore take about 2 tons H2S to the stratosphere, per sortie, with several sorties per day. Each sortie being worth about 10 million pounds of carbon credits. Only one was built, and is quite old now. But maybe the production line could be started up again? Concorde cruised around 60,000 feet. Concorde did use a lot of fuel per passenger mile compared to subsonic jets. However, it is interesting to consider whether it was actually contributing to global cooling, despite the large amount of CO2 it emitted. If the combustion products contained more than 1 part in 152,000 of sulfur relative to CO2, then it would be causing cooling, not warming. Aviation fuels at the time that Concorde was flying contained typically around 0.05% sulfur, corresponding to 1 part in 2,000. See this graph on the IPCC website. In other words, Concorde was cooling the atmosphere due to sulfur emissions at a rate 29 times more than it was warming it by its CO2 emissions. Here is the calculation: 152/2 and divide by 2.6, which is tons of CO2 per ton of fuel. Those who criticized Concorde for being bad for the environment seem to have no idea of this rather surprising fact. In terms of its effect on atmospheric temperature, it was incredibly good for the environment. Quite counterintuitive. There are several projects underway, developing supersonic aircraft, such as the quiet NASA X-59. Also the Boom XB-1 and Overture aircraft, Spike Aerospace Diplomat plane, and exosonic. At hypersonic speeds, the Hermes Quarter Horse and Halcyon, Venus Stargazer plane and the Destinus S are being planned. These planes will probably fly at high altitudes because the air is thinner there, and hence has lower drag. It is likely that they will be more fuel efficient than Concorde. It would be relatively easy to add hydrogen sulfide to sustainable aviation fuel for such aircraft. They would contribute to a significant slowing of heating of the planet. Maybe one tank of fuel without sulfur added could be used for taxiing and takeoff and landing, switching to the sulfur-enriched fuel tanks after reaching cruising altitude. So minimizing sulfur emissions close to populated areas, and hence minimizing health problems. We can envisage a fleet of high-speed drones flying at high altitude to deliver the sulfur at 60,000 feet and above. This is far higher than subsonic passenger planes can fly. They would fly at high speed, in order to maximize payload delivery per day, and to spread the sulfur evenly over a wide area. And they would carry scientific equipment, to sample the concentration of gases at high altitude, and so to confirm efficacy by correlating actual achieved sulfur concentration with radiation measurements from satellites, and to help with the planning of subsequent sorties. You could imagine a flight path of say north-south parallel tracks on one sortie, followed at a relatively short time later a sortie with east-west parallel tracks at the same altitude. Depending on the spacing of the tracks, and the relative timing of the sorties, taking continuous measurements of concentrations and correlating with satellite measurements would quite quickly enhance the scientific understanding of climate sensitivity to high-altitude aerosols. These aircraft might produce a supersonic booming sound, although probably far quieter than Concorde. However, since the maximum benefit of sulfur at stratospheric height is above the oceans, a supersonic boom sound over the ocean is not a problem. Further development of quiet supersonic planes would allow them to fly over land too, and if carrying passengers could simultaneously deliver cooling sulfur to the stratosphere. Human ingenuity is astonishing, we must tap into it to help the climate too. But what if constructing and flying aircraft is beyond your skill and budget? Can you do anything to help with solar geoengineering? On a small budget? Yes, indeed. Anybody with reasonable technical skills has the capability to make a contribution to global cooling. Maybe individually small, but if thousands or millions of enthusiasts around the world would do it, then it really would quickly add up to something significant. Many people want to save the planet from overheating, which we are repeatedly told will be utterly disastrous. And there is no time to waste. We are rapidly approaching tipping points. And if we wait for governments to do something, it will be way too late for the planet. They seem to enjoy endless costly meetings. But practical, technical people just want to get on with it, with minimal fuss. The time for chatting is over. Time for procrastination is over. Time for action now. Action this day. Two enthusiasts are showing the way. They launch balloons. These are filled with a mixture of helium and sulfur dioxide. The balloon bursts at high altitude, releasing the sulfur. There is a small gondola which contains measurement and telemetry equipment. It returns by parachute. Their website is Make Sunsets. You can contribute to their funds on their website. Here are their calculations and references, that 1 gram of sulfur provides cooling to cancel 1 ton of CO2, and, for me, cooling credits seems a far more plausible way to help the planet than carbon credits. The latter may have minimal benefit in some cases. But can we do even better than Make Sunsets achieve? What if we really minimize the gondola weight? There would be more carrying capacity for sulfur. And can we use hydrogen rather than helium? Hydrogen is about half the density of helium, and is way less expensive. Of course there is a risk of it catching fire, but if sensible precautions are taken, wearing a flame-proof suit for example, the risks may be manageable. And H2S rather than SO2, as it is less dense. If the balloon were to be deliberately ignited, once it reaches altitude, we would not be spreading rubber or plastic into the environment. The electronics could be very compact and simple, a lightweight barometric altitude sensor, a very simple microcontroller, and a flashing bright light, to warn pilots. Telemetry and GPS could be an optional add-on module, although adding to the weight. It would have a means to combust the hydrogen and H2S, such as a hot filament as used to ignite model rocket motors, when a preset stratospheric height is reached. A small parachute too, to avoid risk of injury when the miniature gondola falls. If launched on a clear night, you could track the flashing light with binoculars. The electronics would be inexpensive and expendable. But put a phone number on it, in case anyone finds it. These cost figures are speculative, but say you launched 100 grams of sulfur into the stratosphere, what would be your profit? If using the 152,000 scaling factor, this would have the cooling effect of 15,200 kilograms equals 15.2 tons of CO2. A carbon credit per ton of CO2 is around 35 pounds. So 15.2 tons is worth 532 pounds if we use the 1,000,000 scaling. The value of 100 grams of sulfur in the stratosphere is equivalent to 100 tons CO2 equals 3,500 pounds. So now all we need to do is to persuade the buyers of carbon credits to invest instead in cooling credits. Just as there is already a market for carbon credits, there really needs to be a market for cooling credits too. And this has now become extremely urgent. The two entrepreneurs who started Make Sunsets, Andrew Song and Luke Eisman, are really to be highly commended. So far, they have launched 64 balloons, and neutralized 32,785 ton-years of warming. Where did the 10 million pounds for 2 tons of sulfur figure come from? Simply calculate that 2 tons sulfur is equivalent cooling to about 304,000 tons CO2, using the 152,000:1 scaling factor. How much is the cost of a carbon credit per ton? Around 35 pounds in the UK, at the time of writing 304,000 times 35 pounds is a little over 10 million pounds. The UK is prematurely retiring 30 Eurofighter Typhoons. They have plenty of airframe life remaining. These have a service ceiling of 65,000 feet, and a payload of 7 tons. A tank of H2S, plumbed into the fuel line for the afterburners, via a two-way valve to select either normal fuel or H2S. If each performed 3 sorties per day, 3 sorties x 7 tons x 30 aircraft equals 630 tons of sulfur to the stratosphere per day. Multiply by 152,000 gives cooling equivalent to 96 million tons of CO2 heating. Take this in for a moment. The UK could, by repurposing its redundant military jets, provide global cooling equal to the global warming of the whole world's production of CO2. Why don't we just get on and do it? Before reaching tipping points, high-altitude drones would be more cost-effective and would eventually do the task, but they do not exist yet. How much is 96 million carbon credits worth? 3.35 billion pounds per day. That would easily cover the daily cost of operating 30 Eurofighter Typhoon jets. Chapter: Calculation of Transport Fuel Economy. What is more fuel efficient, a typical car, a typical train, or a Boeing 787? Or Concorde? Or the ultra-efficient Aptera car? I definitely want one. We need to calculate not just the miles per gallon of these vehicles, but to make a fair comparison, the miles per gallon per person. But we also need to factor in speed. In general, people are willing to pay more in order to get to their destination quicker. In other words, there is the fundamental equation that none of us can escape: time equals money. Let us compare the fuel economy of different types of transport. The calculations were done for a typical car, typical bus, typical train, typical speedboat, planing hull, and typical light aircraft. Within these categories, yes, individual performances do vary, but there is a general trend of efficiency by category. Then let us also look at some exceptional individual aircraft, and the astonishing Aptera car. This car has been designed to have exceptionally low aerodynamic drag. It is electric, but the equivalent fuel economy is around 300 miles per gallon. At this level of efficiency, it makes sense to include solar panels into its surface. Probably the most efficient production car that may soon be available. The Boeing 787 is one of the most efficient of the passenger planes available. And not surprisingly, it does come out at the number 1 spot. Airbus is also very busy pushing the efficiency envelope. The Diamond DA62 is a high-performance smaller aircraft, carrying 7 people. It has been optimized for fuel efficiency. It has propellers, and so is not as fast as a business jet. They are addressing a different market. But it is speedy, for a propeller-driven plane. It is rated very highly. And of course Concorde. What an amazing aircraft! And you may know that it did use a considerable amount of fuel. Compared to more modern aircraft such as the Boeing 787, the MPG per person of Concorde was about 30% of the 787. But Concorde was more than twice as fast. Factoring that in, Concorde is about 70% of the combined speed and efficiency performance of the Boeing 787, and is about equal to the remarkable Aptera car. Given the enormous strides made, in materials and aerodynamics, it is not impossible to think of a successor to Concorde, with a significantly higher fuel efficiency, a minimal sonic boom, and therefore permitted to fly over populated areas. And using sustainable aviation fuel with enhanced sulfur. Cruising at 60,000 feet or higher, far higher than subsonic aircraft such as the Boeing 787. And simultaneously cooling the atmosphere, more cooling than subsonic aircraft at lower altitude can achieve. You may not feel comfortable with this fact, but high-speed and hence high-altitude aircraft really can play a significant role in reversing global warming. Can you refute the logic? Air turbulence is becoming an increasing risk for passengers and crew alike. Clear air turbulence is difficult to detect, and so has caused significant injuries in recent months. Supersonic aircraft fly higher than the turbulent lower levels of the atmosphere, and so potentially are safer than subsonic aircraft, giving a smoother and more comfortable journey. Chapter: The astonishingly high cost of net zero carbon dioxide. Even if net zero were to be achieved in a short timescale, it would not in itself stabilize global temperature because it takes a significant amount of time to draw down the existing CO2. There is a huge amount of CO2 stored in the atmosphere, and far more in the oceans. It would take many decades for temperature to eventually stabilize after net zero is achieved, due to the existing CO2, even with no more being added, but meanwhile the ongoing temperature rise would result in many tipping points likely being reached, further driving temperature to rise in a runaway manner. So the goal of net zero alone is somewhat a false hope. And extremely costly, both financially and politically, which limits the speed at which it could be achieved anyway. The only economic way to stabilize global temperature, hopefully before reaching the tipping points, is solar radiation management, SRM. If money is a finite resource, it makes more sense to use at least some of it to pay for SRM, rather than splurging the whole budget on net zero, which cannot stabilize temperature anyway in any sensible timescale. For the UK, the cost of net zero has been estimated, by the UK Climate Change Committee, at £50 billion per annum. But the cost of SRM to zero out the UK contribution to global temperature rise would be a few tens of pound millions. The UK economy cannot really afford net zero, but SRM is entirely affordable. It is difficult to quantify exactly how much net zero will really cost. Large projects have a nasty habit of exceeding budget and timescales. But let us make an attempt for the cost to the UK of just cutting its own CO2 to zero. The cost of decarbonising the UK electricity grid has been estimated as £3 trillion, reaching net zero to cost £3 trillion, says National Grid SO. Here is a broad brush calculation of the cost of net zero, based just on the cost of carbon credits. Amount of CO2 emitted by the UK, per annum, 417 million tons, 2022. 1.14 million tons per day. Cost of 1 ton of carbon credit, £35, at the time of writing. Total cost of carbon credits needed for the UK, £14,595 million, £14.6 billion, per annum. UK population, 67.5 million, 2022. Cost per person, £216 per annum. An increasing number of people are very much struggling now, and even 216 pounds is quite a lot to ask of them. For the better off, it may seem like a small amount. But is it value for money? How do we know that the cost of carbon credits accurately represents the cost of decarbonising? The UK Climate Change Committee estimates that decarbonising will cost £50 billion per annum. Therefore it seems that the carbon credits cost is undervalued by a factor of 50/14.6 equals 3.4. So a 1-ton carbon credit should cost around £120. Doing the calculation the other way round. Total cost, £50,000 million. According to Climate Change Committee. UK population 67.5 million, 2022. Cost per person per year, £741. Quantity of CO2, 417 million per annum. Cost per ton of CO2, £120. And what would be the cost, if we offset with sulfur to provide equivalent cooling? Divide these figures by 152,000. So for the UK only 2,743 tons of sulfur per annum would need to be placed high in the atmosphere, and over the oceans. This can be added to aviation fuel and ship fuel, at very nominal cost. Or maybe for negative cost, as oil refineries currently expend cost and energy to remove sulfur from fuels. Additionally, pyrolysis of worn rubber tires produces hydrocarbons similar to kerosene/diesel fuel, with a sulfur content of typically 1.6%. Who would have thought that a waste product, old tires, could help to cool the planet? So, what would the UK rather pay, per annum? £50 billion, just for UK net zero? Or alternatively, a little over £300 million per annum, flying 30 Eurofighter Typhoon jets into the stratosphere, to stabilize the temperature for the whole planet? The UK emits 417 million tons of CO2 per annum, or 1.14 million tons per day. In context, the whole world emits about 100 million tons per day. And so the UK contribution is only 1.1% of the total. The cost of flying one Typhoon jet per year is £10 million. Probably less, though, as quite a number of military subsystems would be stripped out. No bombs or rockets, no DAS, no chaff or flares, no gun. A subsystem that is not installed does not need to be maintained. Just one Typhoon flying 3 sorties on average per day would provide global cooling equivalent to 3 sorties x 7 tons x 152,000 equals 3.19 million tons of CO2 heating, and the carbon credits value is £35 x 3.19 million equals £112 million. In other words, 1 day of flying by just one Typhoon pays for 10 years of aircraft operating cost, while cancelling the UK contribution to global warming nearly 3 times over. Chapter: Marine Cloud Brightening. The oceans have a much darker color, albedo 0.1, than clouds, albedo 0.6 to 0.9. Clouds over an ocean thus reflect far more solar energy than does a cloudless ocean. Can we use this fact in order to cool the planet? Yes, indeed, and at a very small cost compared to all the hot air emitted by climate discussions alone, let alone due to CO2 greenhouse effect warming. The late, and sorely missed, Professor Stephen Salter was a pioneer in wave energy. He invented the Salter-Duck wave energy converter. He also worked out that there is a way to extract more energy from tidal flow than can be achieved from tidal flow turbines of convention propeller shape. These are only able to extract a small proportion of the tidal flow energy, due to their intercepting a circular cross-section part of it, and that they are subject to the Betz limit, that only 59% of the available flow energy can be extracted. However, that limit is true for air, it is not true for water flow, because there is the additional factor of water head, height difference. Salter devised a turbine that blocked a much greater proportion of the flow path, thus creating a water height difference, and so able to extract significantly more of the energy than the Betz limit would permit. The developments of tidal turbines are very much to be welcomed, but if Salter is correct, these propeller-type designs should be considered as interim solutions. We will need to harvest all available energy, if we really are serious about renewable energy. And this factor very much applies to river turbines too. In this context, it is highly regrettable that the Environment Agency is busy destroying weirs. These weirs produce the height difference, that make river turbines such a good solution to help with the energy crisis. Professor Salter also was actively promoting marine cloud brightening. He had designed an autonomous small ship, that would be powered by wind and waves, to pump a fine mist of filtered seawater into the air. Very small particles of salty water are carried aloft. The salt particles then form nucleation sites for water droplets to form clouds, thus increasing albedo very greatly. Salter calculated that a relatively small fleet of around 300 autonomous craft is all that would be needed in order to completely null out the heating effect of the global greenhouse gas emissions. He calculated the cost as around £100 million per annum. In context, the cost of the COP Paris 2015 climate conferences, with 36,000 attendees, increasing every year, can they not do it via Zoom or Skype, is somewhat more than this. So what does the world want? A lot of hot air produced at COP conferences, achieving not very much in reality, or to use that money instead on actually reducing global heating. Here is a video on YouTube of Professor Salter discussing his idea, and how he calculated the relative small cost, and the huge benefit. Marine cloud brightening. Professor Stephen Salter, Tidkar Ryatwat University. Here is a tribute to him, after he died, by those who knew him and appreciated his work. Marine cloud brightening, tribute to Stephen Salter. Here is a graphic rendering of his vessels. It has Flittner rotors for wind-powered propulsion, and hydrofoils for lift, and as these are on hinged beams, the movement of these with waves, via pistons, provides the power to pump the water through a large number of very small nozzles, to produce fine salty mist. In order to reverse sea level rise, just a few hundred of these are needed. If these are deployed strategically, they can help to reduce the severity of hurricanes, avoiding damage that is orders of magnitude more costly than the cost of deploying these vessels. Thus it makes economic sense to just get on and do it. Do it now. The prospect of completely stabilizing global temperature is another good reason to do it. Cruise companies are making eco-friendly ships. Can they be persuaded to fit salt spray equipment too? Chapter: Really caring for the environment. It is easy to become so overwhelmed by the scale of the problems facing the natural environment. But what can you do locally to you, that would make some difference, some improvement? We should be concerned about the health of rivers, because their health is an indicator of the wider environmental health. Rivers are the canary in the coal mine. And during the summer months, a healthy river can be a source of joy, whether you take a stroll along its banks and see the abundance of wildlife, or whether you take the plunge and experience wild swimming. This is quite unlike swimming in an indoor swimming pool. You are there, literally immersed in nature. If you are still for a short time, quite soon the small fish gently nibble your feet. And what an experience, with dragonflies darting around above you, and the brief glimpse of a kingfisher flashing past, or even a pair of otters playing together. It really is magical. When I tell people that I regularly swim in the river, almost invariably the response is that they would not do so, because it is so polluted and disease-ridden. Unfortunately, they do have a good point. Pollution, mainly from sewage works, but also from livestock farms, can be quite off-putting, particularly when the sewers overflow after heavy rain. The water quality in UK rivers is in a dire state. Unfortunately, it does seem that only through pressure from volunteers does very much get done to improve river water quality. Here is a recent article, but there are many similar examples. Poisoned by chemicals, citizen scientists prove River Avon is polluted. Charity says the decline of invertebrates linked to chemicals in water, while Environment Agency said Wiltshire River had not deteriorated. Adequate oxygenation of the water is a key aspect of helping to break down pollutants. Unfortunately, if the water is allowed to be too shallow, it then overheats during the summer. The warmer water cannot hold as much dissolved gas, including oxygen, and this harms invertebrates and fish. Fish must have a certain minimum of oxygen in order to be healthy, and in order to be able to reproduce. For there to be a healthy fish population, they need greater than 9 ppm, mg/L, of oxygen. See this table. For the case of fresh water, i.e. rivers, the temperature should not be allowed to increase above 20 C, or there will be inadequate dissolved oxygen. When I swim in a river on a hot summer day, I often notice a temperature gradient with depth. Just upstream of the weir at the swimming spot, the water depth is about 2 meters, and the deepest layer is noticeably cooler than the layer at the surface. And it seems obvious, the sun radiation is strongest at the surface, and attenuates significantly with increasing depth. The water depth becomes increasingly shallow upstream of the weir. Then at about 500 meters upstream it is too shallow to swim, at only about 0.2 meters depth. And very noticeably in these shallower regions the water is appreciably warmer than in the deeper region. And as shown in the table of oxygen solubility in water, this hotter shallower region cannot hold as much oxygen as the cooler deeper region by the weir. This is quite a basic level of understanding of natural processes that fish need deeper water, particularly in warmer weather, a principle which needs to be applied to the proper management of rivers. And yet, the Environment Agency seems not to understand or apply even this simple scientific fact. Their policies of river mismanagement, removing weirs, and not permitting dredging, have the effect of making rivers more hostile for wildlife to live healthily. It also ought to be obvious that an excessively shallow river, stagnating, simply causes any added sewage etc. pollutants to become more concentrated due to the much smaller volume of water that they mix into, and hence is even worse for biodiversity. There are numerous projects to reconnect rivers by removing or notching weirs. And yes, it is true that this does allow fish to move more freely up and down, where previously there was the weir, which is an impenetrable barrier for many species of fish that do not jump past barriers. But the solution needed must surely be to install fish passes, thus retaining the head of water needed for depth, while at the same time allowing the up and downstream passage of fish. Anglers will tell you that fish are attracted to deeper water. But just observe where anglers most often congregate, and that immediately tells you where the fish are to be found, where the water is deeper and certainly not where it is very shallow. Anglers really do have the best interests of fish at heart, because without fish, there can be no angling. Where there are fish there is a healthy food chain, and hence a healthy river. And so it is significant that anglers oppose the removal of weirs, but are overridden by the Environment Agency. Where is the logic in that? Does the EA care about fish or not? It is disheartening to see photos of rivers after weirs have been removed, showing hardly any water remaining. It is perplexing that anyone would think that a shallow trickle of overheated water, with pollutants much more concentrated, because the volume of water is much less, is a better habitat for fish than a deeper, cooler flow. Can those who advocate such action please examine the tables or graphs of oxygen solubility in water, as a function of temperature? That fact alone ought to be enough to persuade any reasonable person that removing weirs is an immature policy not well considered at all. Here are photos of the River Aire in North Yorkshire, before and after the Coniston Cold Weir was removed. After weir removal, the water is very shallow, and prone to drying out completely, not good at all. Shallow water makes fish very vulnerable to predation by herons, as well as vulnerable to drying out and overheating. Just crazy that anyone thinks it helps. The first photo is before the weir was destroyed, good depth of water, and excellent aeration. The second photo shows the same location now shallow with zero aeration. Fish avoid very shallow water, rubbing against stones strips off the protective mucus layer from their scales, making them vulnerable to infection. Weirs are also excellent for aerating the water. I have measured dissolved oxygen levels immediately downstream of a weir some 50%, 100% higher than oxygen levels upstream of the weir. It makes all the difference to whether fish can spawn or not. They cannot do so if the oxygen percent is too low. A piano key weir has a shape that greatly increases the length of the weir edge for a given river width, compared to a straight weir. This shape therefore allows a significantly greater discharge flow. This is particularly important during flooding conditions. This type of weir thus does not add significantly to flood risk. It has a far greater discharge efficiency than a straight weir. The greater length also increases the oxygenation, because the surface area that the water has with the air is greater. If an existing weir needs restoration, the possibility of implementing it as a piano key type should be seriously considered. Fish passes can be incorporated at the sides of weirs. Fish tend to swim upstream by following the edges of the river, and this does make sense, because the water generally flows more rapidly in the center than by the banks. Therefore, the optimum position for a fish pass is adjacent to the river bank, rather than in the center of the weir. Often a weir is placed diagonally across the river, and if it is practical to do so, the fish pass would preferably be located at the further upstream end of the weir, thus giving fish the greatest chance of finding the entrance to it. Additionally, if there is a flow of water to attract the fish, say from a hydroelectric turbine outlet, it is preferable for this to be near to the entrance of the fish pass. The fish are attracted to flowing water. Of course, the speed of water flowing out from a turbine would be too fast for them to be able to swim against, but once they are in that vicinity, they should soon find the slower flow coming from the adjacent fish pass. There are very many different types of fish pass, in a large variety of shapes and sizes. They may be constructed of concrete, metal, rubber, or plastic etc., or naturalistic using stone boulders. The naturalistic type tend to be very inefficient hydraulically, requiring a very shallow slope, and hence require a huge tonnage of stones, i.e. expensive, and wasting water, but looking more aesthetically pleasing. It can be an option if you are not interested in retaining a depth of water. However, in reality the fish do need a depth of water to be healthy, so a more man-made type is in fact preferable. In general, whatever design is used, fish passes act to slow down the water as it flows down a slope. Most smaller fish, coarse fish, can only maintain a speed of about 0.5 meters per second, and so a fish pass should be designed to slow down the flow to below this speed. Larger fish such as trout can maintain a faster speed. Fish can swim faster in short bursts, but if the fish pass requires such speed bursts, it would have to also incorporate resting areas. A new type of fish pass is under development, which CFD, computational fluid dynamics, simulation and initial prototype testing indicates may be around 3 times more effective at slowing down the water, for a given gradient, than existing designs. Thus it gives the potential for considerable cost savings relative to existing designs. Beavers have been reintroduced into several rivers. They require a certain depth of water in order to thrive. Rivers with existing weirs are ideal for them. But if the weirs are removed, then beavers will create dams in order to raise the water back to its previous level. Why not just leave the weirs in situ? Beavers then can use their energies to make their dwellings. Those who want to introduce beavers whilst simultaneously removing weirs are not being logical. Their dislike of weirs can only be for aesthetic reasons, not for ecological or scientific reasons. A beaver dam is as much a barrier to fish passage as is a weir. Why not, instead of expending large sums of money on weir removal, use that money to install fish and eel passes at the weirs? Thus also leaving these long-established pieces of infrastructure available for installing micro-hydroelectric turbines. We are facing an extremely serious energy crisis, as well as a climate crisis as a result of burning fossil fuels. Therefore there is increasing pressure to tap into natural sources of energy, rather than being so reliant on fossil fuels. We urgently must get off our dependence on fossil fuels, both for environmental reasons, and for geopolitical reasons. The world is almost certainly past peak oil now, and so it can only become more scarce and expensive from now on. It takes an amount of energy to extract oil from the ground. In the North Sea, oil rigs are now using electricity from wind turbines when formerly they were powered by electricity from gas-powered turbines. See this video, Global Oil Depletion. Alistair Hamilton. There are many natural sources of energy which have still to be fully tapped: hydro turbines in rivers, which in the UK have the potential to produce around 1 GW of electricity, and tidal flow, which around the UK coastline has the potential to generate 10 GW. Tidal range projects in the River Severn estuary have been repeatedly blocked, ironically, for environmental concerns. Hydro turbines in UK rivers have de facto been blocked by the Environment Agency. They do not permit the restoration of damaged weirs. The EA threatens weir owners with court action if they do restore it. Do they see the irony in their stance? The Environment Agency is busily removing weirs from rivers in Cumbria, the Lake District, Gloucestershire, and Yorkshire and elsewhere, and also strongly discourage dredging, and then wondering why the rivers dry out in the summer, and the fish perish. Article from July 2022, Weir Today, Gone Tomorrow. Work starts to free Cumbrian River. Article from June 2023, River in wettest place in England in Lake District almost completely dry. The weirs were originally constructed, many years ago, in order to create a head of water, which, via a water wheel, was then used for grinding corn, or manufacturing cloth, etc. During the dry summer months, the weirs hold back the water, thus creating an excellent habitat for biodiversity. And importantly, the weirs aerate the water too, also vital for biodiversity. There are modern water wheels too, and these generate electricity, and so are helping to reduce our reliance on fossil fuels, and so help reduce CO2 emissions. The government really must be more encouraging of micro-hydroelectricity generation. Yes, individually they do not produce a large amount each, but it can all add up, given the many thousands of sites. Here is an example in the Lake District. Today, it is relatively straightforward to add a fish-friendly turbine adjacent to each weir, and a fish pass to help the fish travel upstream too. There are several designs of fish-friendly turbines now available. These allow the passage of fish going downstream without injury. For example, the fish-safe turbine made by Natel Energy, Restoration Hydro Turbine, has a curved leading edge of the blades, and which is also more rounded than the sharp blades of existing designs of conventional turbines, which are not fish-friendly. There are other designs of fish-friendly turbine available, but Natel Energy seems to have done some of the most comprehensive testing to prove the effectiveness of their design at avoiding harm to fish. Individually, a turbine can produce a few tens of kW, but in total, across some 20,000–30,000 sites in the UK, there is the potential for about 1 GW. Which is significant, as the hydroelectricity is available 24/7, particularly during autumn/winter/spring, when solar is at a minimum. The installation cost per kW capacity of micro-hydro turbines is far below the construction cost of Hinkley Point C nuclear power station, £46 billion. And see this article in the Telegraph: new nuclear power plant expected to kill 46 tons of fish a year. EDF building £50 million nature reserve near Hinkley Point to compensate for loss of life. Hydropower does drop off during the summer, but that is when solar electricity is at a maximum. I really do wish that the Environment Agency could be persuaded that micro-hydro in rivers is in fact good for the environment, both ecologically and climatically, and that weirs are good for biodiversity. If weirs could be restored, they produce a head of water, and hence a turbine can make electricity. But the Environment Agency prefers weirs to fall into disrepair, and threatens weir owners with being taken to court if they do restore them. But without weirs, the rivers dry up in the summer, the water stagnates, and without aeration over a weir, the dissolved oxygen drops to low levels, seriously harming biodiversity. Additionally, the EA discourages dredging. A lack of dredging leads to severe flooding in winter, while causing the rivers to be too shallow during summers due to the buildup of silt, and hence too hot, so too little dissolved oxygen, and therefore not healthy for fish. We must help the environment who wants stagnant, unhealthy rivers. The EA appears not to clear obstructions such as tree trunks blocking the flow between bridge piers, despite being phoned about the problem. This must surely be contributing to flooding too. The Department for Environment, Food and Rural Affairs must get a grip on the EA. If there were some sane policies in place, the EA should in fact be paying weir owners to restore weirs to their original height, and to install fish passes and hydro turbines. At the moment, the EA has de facto banned hydro turbines, because they do not allow weir restoration. Turbines need a head of water to operate. Given the severe energy crisis and the climate crisis, we really cannot afford or indulge the current policy that the EA is following. What is the social and economic cost of failure of the EA to dredge rivers, and hence adding to flooding? The National Farmers Union is concerned that the widespread flooding will severely impact crop yields. Reduced yields will push up food costs even higher, at a time that so many people are already struggling. Article: Our yields are going to be appalling. One of wettest winters in decades hits England's farms, and if a farmer were to take the initiative to dredge the river himself, to prevent flooding, after years of neglect by the EA, they are sent to prison and heavily fined. How can this be right? Questions have been raised in the mainstream press regarding the behavior of the chairman of the Environment Agency, Alan Lovell. The Daily Mail reports that he was treated to expensive meals by water companies, and to hotel stays. Environment Agency chief had dinner with water company lobbyists days before plans for 40% bill hikes were reported, Lib Dems reveal. The Daily Mail article reports that he received hospitality from Water UK, Yorkshire Water, and Severn Trent Water. Meanwhile, the water companies are responsible for hundreds of thousands of hours of sewage emissions into rivers. The EA should not be receiving any gifts at all from such companies, because it should be obvious that this compromises their moral character, and their authority to deal with pollution. The EA chairman had already been criticized by the mainstream press, for his alleged conflicts of interest. See this article: Prospective EA chair refuses to divest from firm chosen for government project. If only the Environment Agency could focus upon reducing pollution in rivers, without seemingly having a chummy relationship with water companies, that would be greatly to the benefit of the environment. Can it also have a much more rational approach to weirs, fish and eel passes, and dredging of silt, where judiciously needed to reduce flood risk, and a proactive clearance of blockages such as debris buildup at bridges, which clearly contributes to flooding? Given the urgent need for electricity generation from renewable resources, both because of the energy crisis and the climate crisis, it just seems utterly absurd that the Environment Agency is acting as the main blockage and impediment of micro-hydro projects in UK rivers. Instead, they should be positively encouraging weir owners to install fish-friendly turbines and fish and eel passes. If there was a rational argument for the existence of the Environment Agency, they would indeed be giving grants to weir owners, towards the cost of installation of such beneficial infrastructure, rather than threatening them with prosecution for restoring weirs. It should be self-evidently the right action to restore weirs, and encourage turbine installation. Not only are micro-hydro turbines in rivers far less expensive to construct than Hinkley Point C nuclear power station per kW capacity, there is no nuclear waste from hydro. Nuclear waste has to be stored securely for thousands of years. In summary, weirs should not be removed because 1. Weirs are excellent at aerating the water. I have an oxygen meter, and measured the dissolved oxygen content, which is significantly higher downstream of the weir than upstream. 2. Weirs make deeper water, hence protecting fish from predators such as herons. 3. The deeper water is cooler, hence can carry a higher percentage of oxygen. Shallow overheated water is really bad for fish, as the oxygen levels get dangerously low. Simple O-level physics: gases are less soluble in hotter water. 4. Allow bathers to enjoy swimming. Upstream of a weir the water is deep enough to swim. Without weirs it would be too shallow. 5. The larger volume of water is less badly affected by sewage overflow, as the sewage is more diluted. In reality, there will be discharges from sewage works for the foreseeable future. Weirs help to mitigate the ecological harm. 6. There are beavers in the river. They like deeper water. And if it is not deep enough, they cut down trees to dam it. Are there enough trees nearby for them to do this, if the weirs are removed? And if they do make dams, these would block the passage of fish anyway. The Environment Agency's aim to reconnect the rivers cannot logically be achieved unless the beavers are first removed. Chapter: The Moral Case for Private Action. As discussed in earlier chapters, net zero CO2 simply cannot stabilize the global temperature in a timely manner before serious tipping points are reached. We do have an option: solar radiation management, also known as solar geoengineering. This has been identified as a credible option decades ago. It is not an either/or choice. We can do both. But the proponents of net zero are not taking the sheer scale and urgency of climate change measures seriously enough. They must surely know that net zero has no chance of working quickly enough. Governments and pseudo-government organizations have had decades to do solar geoengineering, but have utterly failed to do anything at meaningful scale. If global heating really is the serious situation that we are frequently told that it is, and with increasingly serious severity, then private companies and philanthropic wealthy individuals need to fill the gap. And do so without delay. Waiting for dithering governments to act will mean that we far overshoot many tipping points, thus making it doubly difficult to do corrective action, when at last these governments finally decide to act. Two approaches have been described in this book: the use of sulfur dispensed, preferably, in the stratosphere, and as a secondary preference far out at sea. And fine spray of sea water, out over the oceans, for marine cloud brightening. But we need to realize that some people do not like chemicals, even though sulfur is a necessary building block of all life forms on Earth. We would not exist without sulfur. And at levels needed in the stratosphere, it is at least 2 orders of magnitude lower than is harmful to human health. If there is too much opposition to sulfur, then as an alternative, or stopgap, then salt spray needs to be deployed with great urgency right now. Nobody can object to salt. Why would anybody pay? We can set up a cooling credits market, and companies and concerned individuals can buy these credits, in order to offset their own contribution to global warming. Carbon credits have this aim, but in reality some of the projects that they fund are of questionable value. Yes, trees do soak up CO2, but so did the plants that were growing in the areas where the trees are planted. It is disingenuous to only count the tree absorption CO2, without subtracting the CO2 that the existing plants would have absorbed anyway. Those who are selling cooling credits into the market, would have very rigorous independent checking of the efficacy of their techniques, whether spraying salt mist, or placing sulfur in the stratosphere, or by other new techniques not yet considered. Insurance companies would find it in their best interest to fund it too. The strength of hurricanes would be reduced by spraying salt water. It cools the sea, so there is less heat energy to drive hurricanes. If it results in even a 10% reduction of insurance claims, then that would very easily pay for salt spraying in the ocean regions where hurricanes develop. In the Caribbean would greatly protect the east coast of the USA. In 2005, Hurricane Katrina caused immense damage in the USA, estimated cost at well over $100 billion, with the tragic loss of 1,836 lives. Here is its track. We cannot claim that salt spray would completely eliminate the threat from hurricanes. But suppose it did reduce the damage cost by 10%. That is $10 billion saving in the case of Katrina. A few years ago, Professor Stephen Salter calculated that a fleet of saltwater spraying vessels would cost £100 million. Okay, allow for inflation, that is still far lower, by 2 or 3 orders of magnitude, less than the cost of a major hurricane. And many thousands of lives would be saved too, over the years, by reducing hurricane severity. Professor Salter and others have started an organization, Re-Brighten. The moral case for urgent action by non-government organizations has been published in this paper, Legitimacy and Justifiability of Non-State Geoengineering. If we wait for governments to act, we could be waiting for several decades. We cannot afford such ongoing delays. Chapter: The Mandatory Nature of Moral Action. In 1972, Peter Singer published a paper, Famine, Affluence, and Morality. He argued that those who are affluent have the moral obligation to help those who are in desperate need. One of the core arguments of this essay is that, if one can use one's wealth to reduce suffering, for example, by aiding famine relief efforts without any significant reduction in the well-being of oneself or others, it is immoral not to do so. Singer introduces the drowning child argument or drowning child analogy. According to Singer, inaction is clearly immoral if a child is drowning in a shallow pond and someone can save it but chooses not to, nor does placing greater geographical distance between the person in need and the potential helper reduce the latter's moral obligations. Here is the thrust of Singer's argument. 1. Suffering and death from lack of food, shelter, and medical care are bad. 2. If it is in our power to prevent something bad from happening, without thereby sacrificing anything of comparable moral importance, then we ought, morally, to do it. 3. It makes no moral difference whether the person I can help is a neighbor's child 10 yards from me or a Bengali whose name I shall never know, 10,000 miles away. 4. The principle makes no distinction between cases in which I am the only person who could possibly do anything and cases in which I am just one among millions in the same position. Today, we can apply these moral principles to stabilizing global temperature. 1. An uncontrolled rising temperature is bad. 2. It is indeed within our power to stabilize temperature, using known techniques that do work, marine cloud brightening, and aerosols in the stratosphere. 3. We would do this for the whole of humanity. 4. We each are obliged to do this, whether in a group or individually. Chapter: What can concerned enthusiasts do? If you have a small budget, can you do anything to help with solar geoengineering? Yes indeed, and the Make Sunsets organization is doing something. Small, and maybe symbolic on their scale, but if thousands of enthusiasts around the world were to do the same, it could add up to something significant. They are just 2 people, launching balloons into the stratosphere, containing sulfur dioxide and helium. I have written to them, suggesting instead the use of hydrogen sulfide and hydrogen in the balloon to improve efficiency, and a very small, i.e. very lightweight, a few grams electronic controller, containing a barometric altimeter sensor, and a microcontroller, and a commonly available igniter for model rockets, to ignite the hydrogen and hydrogen sulfide mixture at a predetermined altitude, say 55,000 feet. The controller would be expendable, descending on a small parachute to avoid any possibility of injuring anyone. There are grandfather rights that permit weather balloons to be launched, but of course notifying the aviation authorities, FAA, CAA etc., so that launches can be notified to airmen, NOTAMs. GPS and telemetry can be added, but commonly available GPS is deliberately restricted not to work above 59,000 feet. There are numerous amateur groups launching balloons, NC Near Space Research, AMSAT UK High Altitude Society and many others. At a step up from this, a model glider can be used, attached to a balloon. The advantage is that it could be fitted with an ADS-B transponder, so that air traffic controllers, and all aircraft in the area would see instantly where it is, and be able to avoid it. Powered aircraft are obliged to avoid gliders and balloons, just as powered boats are obliged to avoid sailing boats. Common sense must be applied, and not do this anywhere near an airport or flight path corridor. At altitude, the glider would release from the balloon and glide back to the launch point. Someone has already been doing something similar, and attained an altitude of 90,000 feet, see YouTube Cloudless, Near Space Glider 90,000 feet release. What an amazing video, showing a model glider at very high altitude, with the curvature of the Earth clearly visible. Surely any radio control hobbyist would want to get involved in such an activity, particularly if they can derive a comfortable income by selling cooling credits into the marketplace. And better than that, they would feel a sense of virtue and purpose, helping to stabilize global temperature, while doing something fun and exciting. And they would undoubtedly post their videos on YouTube. A friendly rivalry league table would show who could deliver the most sulfur to the required altitude per sortie. Maybe 2 kilograms to 55,000 feet altitude can be achieved. Having a monetary value of cooling credits of an anticipated equivalent to 2x 1000 x 35 pounds equals 70,000 pounds, which is not bad for a few hours of enjoyable work. 35 pounds is the value of 1 ton of CO2 carbon credits at the time of writing. Assuming 1 ton of sulfur cancels 1 million tons CO2. Here is a screenshot from the video. The altitude is 25,106 m, 82,368 feet. Others are doing glider drops too, on YouTube drone drop at 105,000 feet. And space glider, FPV to space and back. And NSL-49 glide from 115,000 feet. If the glider is attached to the balloon oriented upside down with the nose of the glider above the horizon, then it will be able to move forward and steer during the ascent. Hence it can stay fairly close to the launch location, vertically above it during the ascent, and hence have a much better chance of returning directly there during the descent. The ADS-B transponder is fairly expensive and it is preferable to recover it, together with high-quality video of the flight. It may be that gliders and balloon and sulfurous gases are not what you feel comfortable with. Instead, you can make drone boats, that go out to sea, and spray a fine mist of salt water into the air, for marine cloud brightening. Professor Stephen Salter designed a small ship to do this. With Flittner rotors for propulsion by the wind, and moving hydrofoils. He calculated that just 400 of his ships would provide sufficient cooling to cancel out the warming of the whole planet. But imagine 4,000 drone boats, each 1/10 of the size of the Salter boat. Very achievable, and at relatively low initial cost. A hobbyist is not restricted to that particular design. They may, for example, make a solar-powered boat on a much smaller scale, a few meters length, using a canoe, rowing boat, or surfboard as the basis for it. Solar panels can be lightweight and flexible. There are advantages to a monohull with a weighted keel. If it capsizes, it can quickly right itself. Battery and motors can be in the keel. Telemetry could be via long-range radio link, LoRa etc., or via satellite. It would be good if larger vessels can see these small drones, and so they should be fitted with a radar reflector, and with an ACE, anti-collision information system, transponder. These transponders automatically communicate with transponders within a few miles, and hence allow vessels to maneuver in ample time to avoid collisions. Here is an example of solar-powered drone boat, to show what is possible. Hobbyists can really deploy balloons and drone boats at scale, and at relatively low cost. Many have 3D printers democratizing manufacturing, sharing the design files. There are millions of radio control hobbyists around the world. No waiting endlessly for governments to do something effective to cool the planet, we can just get on and do it straight away. For the good of the planet's ecosystem, and for the good of humanity. It would feel good, and is right and moral to do so. And earning a good, well-deserved income. Chapter: How high is the stratosphere exactly? For aerosol deployment into the stratosphere, we need to know at what height it starts. And, as you can imagine, this has some complications. This article states, near the equator, the lower edge of the stratosphere is as high as 20 kilometers, 66,000 feet, 12 miles, at mid-latitudes around 10 kilometers, 33,000 feet, 6.2 miles, and at the poles about 7 kilometers, 23,000 feet, 4.3 miles. The higher that the aerosols can be deployed into the stratosphere, the more effective they will be. It is anticipated that, at least for deployment by amateur enthusiasts, most deployments will be done at mid-latitudes, in USA, UK, Europe, India, China, and in the Southern Hemisphere, Australia and New Zealand. As an initial working theory, we should aim for a challenging yet achievable goal. My suggestion is to aim for between 50,000 feet and 59,000 feet. This lower figure is significantly above that which commercial airlines can fly at. The upper limit is a practical limitation. Inexpensive GPS receivers that are readily available do give an altitude measurement. However, to avoid them being used in military missiles, they deliberately will not operate above 59,000 feet. In order to use GPS for altitude measurement of the aerosol deployment height, a telemetry radio link will send the GPS position, latitude, longitude, and altitude to a ground station, together with an indication that the aerosol has been released. The telemetry data would be saved and used as evidence that the release was at the desired altitude. Payment for cooling credits would be according to quantity of aerosol released, and according to altitude. If 50,000 feet or higher is achieved, then there would be full payment. And below that, a sliding scale down to zero payment if it fails to get off the ground. The higher the better, but to optimize effectiveness it is easier to transport a larger quantity of sulfur to 50,000 feet than 100,000 feet. Chapter: Are carbon credit schemes a massive fraud? Carbon credits are being purchased by large corporations whose business models lead them to emit large quantities of CO2, to claim that they are net zero. This claim helps them to bolster their credibility with the public, and so also helps their share price. Those who run the projects to produce carbon sequestration are probably doing so with the best of intentions in most cases, rather than being deliberately fraudulent, but the question must be asked: are their claims accurate and realistic? And are their actions done at a cost of CO2 emissions in some other way, that they have not accounted for? For example, if they turn arable land into forest or marsh, have they accounted that the food must then be transported further, which involves emitting CO2 from transport fuels? Some carbon credit projects are useless. Guardian newspaper article revealed, more than 90% of rainforest carbon offsets by biggest certifier are worthless, and on YouTube how the net zero investing market became worthless overnight, and an article, 7 reasons why carbon offsetting doesn't work, and many others. It is not merely a problem of money. If someone unwarily buys carbon credits that are worthless, then that is their problem. It is worse than that. The accountancy balance sheet of CO2 cannot balance. Atmospheric CO2 will increase, no matter how much CO2 is falsely claimed to be captured. Schemes can be positively harmful too, turning arable land into marsh or peat bog. These release copious amounts of methane, which is a far more potent greenhouse gas than CO2. The UK Environment Agency deliberately turned 700 acres of rich arable land into salt marsh, west of Chelsea. I lived nearby, and know it caused great distress to residents, several friends too. A Dutch woman affected could not believe the stupidity. Chapter: Cooling credits versus carbon credits. A cooling credits market needs to be established as a means to help stabilization of global temperature. There is an existing market for carbon credits, that was established several decades ago. The carbon credit market was valued at $103.8 billion in 2023 and is set to grow at a CAGR, compound annual growth rate, of 14.8% during 2024 to 2032. The price of carbon credits does fluctuate, and it is anticipated that the price of cooling credits would do too. As described in the previous chapter, there is an increasing realization that many carbon credit schemes are problematic. Unless this can be addressed, it is likely that the bubble will burst, and their value plummet. Cooling credits need to be, and almost certainly will be, far more transparently beneficial to stabilize global temperature than carbon credits. Suppliers of cooling credits must measure exactly how much sulfur they are taking to the stratosphere, or how many tons of salt water spray they are delivering above the ocean. And they need to log precise latitude, longitude, and altitude locations, together with date and time and quantity of release. And thus the results on cooling can be measured in near real time, within hours or days, rather than years or decades, by means of satellites. Satellites are already deployed and are measuring solar flux across the whole area of the Earth. And it is these satellites that have measured the inadvertent geoengineering experiment conducted by the ships with low sulfur fuels. The significant increase of solar radiation entering the oceans has been quantified. Several climate researchers have been ringing the alarm bells regarding this. Look up Dr. James Hansen and Dr. Leon Simons. Look up their paper Global Warming in the Pipeline and Leon Simons, Aerosol Demasking and Global Heating. The map shows the sulfur emissions from ships prior to the ban on sulfur in ship fuel. Many shipping routes are in the North Atlantic and North Pacific. And it is in these areas now that there is a very large increase in solar flux. The oceans are warming up because sulfur has been cut. Urgent cooling is needed to reverse this serious error. Saltwater spray is probably the most acceptable means to do this now. Saltwater spray is being used right now to help keep the Great Barrier Reef cool, and hence to avoid so much coral bleaching. Deployment is currently on a relatively small scale, but cooling credits could fund a greatly expanded scheme. They use a machine that is already available to produce mist. They were developed to reduce dust in dusty environments such as construction sites. The value of any commodity does depend on the supply and the demand. At the time of writing, 1 metric ton of CO2 that is removed from the atmosphere is worth about 35 pounds. There would be an exchange rate between cooling credits and carbon credits. It is anticipated that the relative value would vary, but let us estimate what it would be initially. Professor David Keith estimates that 1 ton of sulfur in the stratosphere has the cooling effect to cancel out 1 million tons of CO2. This figure is used by Make Sunsets. They release balloons containing sulfur dioxide. If 1 ton of CO2 is worth 35 pounds, and the exchange rate is 1 million to 1, then 1 ton of sulfur in the stratosphere is worth 35 million pounds. More research is needed to give a refined measurement of the exchange rate. But whatever it is a very large number indeed. It is likely that cooling credits will supersede carbon credits, as they will be seen as far more immediate, direct, and measurable. And honest and reliable. With confirmation of deployment in near real time by satellite monitoring. Unlike many carbon credits projects that take years or decades to come to fruition, it takes 20 years for trees to grow to any substantial size, for example. And no certainty that they will not be chopped down once they reach a useful size. Some carbon credit projects are highly questionable. Turning arable land into peat bogs, for example, is likely to release just about as much methane by volume as CO2 absorbed, once it is established, and methane is some 80 times more potent a greenhouse gas. It would need to emit not more than 1.25% as much methane as CO2 absorbed, for it to even break even in terms of warming, which is highly unlikely. Wetlands account for approximately 20–30% of atmospheric methane. See Wikipedia article Greenhouse gas emissions from wetlands. If you want something to be done, it is necessary to discuss how it is funded. Hence there is a necessity for a market for cooling credits. Academics may be disparaging of those who use a functioning market. They are insulated from this necessity, as their research is funded from the public purse. The public is unable to control what is funded. Public funding of research is equivalent to going into a shop, your wallet forcefully taken by the shopkeeper, who then obliges you to take away an item that you do not want, and did not ask for. If cooling projects demonstrate effectiveness, their value will be in strong demand. And their monetary value will reflect that demand. And the market will ensure that it actually happens at scale. Chapter: Who is opposing solar geoengineering, and why? One of the vociferous opponents of solar geoengineering, not just high-altitude sulfur, but saltwater spray too, is Professor Raymond Pierre Humbert of Oxford University. Let us examine his publications to work out what his objections are. And let us contemplate whether these are valid objections or not. Especially in the context of accelerating heating of the planet, which existing measures have utterly failed to address. And the context of thousands of lives lost in hurricanes, a significant number could be prevented. Pierre Humbert has been opposing solar geoengineering for many years, and has a prominent position advising UK government, via the National Research Council, NRC. Here is a quote from an article he wrote in 2015, "The idea of fixing the climate by hacking the Earth's reflection of sunlight is wildly, utterly, howlingly barking mad." From the article it seems his objections are: 1. He describes it as climate hacking. 2. He is concerned that it may be a big mistake. 3. Solar radiation management he thinks cannot be managed. 4. He prefers the term albedo hacking rather than albedo modification. 5. He objects that marine cloud brightening and stratospheric aerosols only persist for weeks or years, whereas he claims CO2 persists for far longer. 6. Climate intervention he states would need to persist for millennia. 7. He does not think that albedo modification would buy us some time to address CO2 emissions. 8. He thinks that tethered balloons and stratospheric aircraft would be attractive targets for terrorists. 9. He does not think that temporary deployment scenarios are plausible. 10. He thinks that albedo modification can have little effect. 11. He is concerned if albedo hacking were to end abruptly. He thinks there would be a rapid increase in temperature. 12. He thinks it would produce diffuse sunlight, altering the environment for all green plants on land. 13. He is concerned that albedo hacking would alter rainfall patterns, winds, and regional temperature. 14. He points out that the current state of climate models are inadequate to model intervention outcomes. 15. He states that albedo modification does nothing to reduce ocean acidification due to CO2. 16. He thinks that albedo modification would remove the incentive to decarbonize. 17. He thinks that research into albedo modification should not be done at all, because he thinks it is ungovernable. Read the article for yourself, and consider your responses to it. Here are my responses, point by point. The numbering corresponds to the points numbered above. Responses to the article. 1. That is a derogatory belittlement of years of serious research. 2. It can be stopped at any time. If ongoing monitoring identifies serious unintended consequences, then the effect can only last for a finite time after cessation of deployment. 3. The effectiveness of solar radiation management can be monitored in near real time, via satellite. Management would be done to ensure it is targeted where and when needed. According to season on a timescale of months, and according to weather patterns it can be adjusted on a timescale of hours and days. For example, to reduce the risk of hurricanes, marine cloud brightening could be targeted in the Caribbean at the time of year of maximum sea temperature, which is the main risk factor for hurricanes. 4. The use of the term hacking is derogatory. Serious concerned scientists have spent large parts of their careers investigating it in detail. The word hacking implies some spotty teenager doing bad things which are against the law. Name-calling is not a good approach to a rational discussion. 5. He is being blatantly inconsistent. If point 5 is true, how can points 2 and 3 be true? If this hacking can have little effect, how can it simultaneously be extremely dangerous and unmanageable? 6. Not true. We are probably well past peak oil and gas already, and if so, then CO2 emissions have a finite duration. Maybe a few more decades, certainly not millennia. On the timescale of millennia we probably will be entering the next ice age. Burning of fossil fuels might slightly delay the next ice age, but cannot avert it indefinitely. Slightly is in the context of the ice age cycle, of around 100,000 years. 7. Completely wrong. Albedo modification definitely would buy us some time to get CO2 emissions under control. Stabilizing temperature is a worthwhile goal in itself. Reducing the severity of hurricanes via marine cloud brightening would save many billions of property damage, and avoid many thousands of deaths. 8. Balloons would be free-flying, like every weather balloon, not tethered. I have never heard of a weather balloon being used in a terrorist attack. It is quite an absurd suggestion. Balloons cannot be steered accurately to a target, so how would a terrorist conceivably use it? Besides, large balloons are readily available for the public to purchase. If a terrorist wanted to use one, they would have done so already. Additionally, a 60,000 feet tether would be so heavy that there would be little carrying capacity for payload, and would be unmanageable. Maybe the professor has images of barrage balloons? During WW2 their tethers were typically 2,000 feet to 5,000 feet. If ex-military jets are used, such as Eurofighter Typhoon, these would most likely be operated from military bases, where there is very little opportunity for terrorists, armed guards at the gates. And what would they do anyway even if they reached the aircraft? It is an absurd argument. That the professor makes such bizarre objections calls into question all of his objections. We need to be rational and realistic if we are to tackle global warming. 9. Yes, it can be temporary, if that is what is required. A few decades is the likely scenario, as renewable energy sources ramp up, and energy usage efficiency improves. As oil and gas become increasingly scarce, so CO2 emissions will drop increasingly rapidly. 10. If albedo modification can have little effect, why worry about it? Why not just let those who are enthusiastic for it give it a try? And if they achieve nothing measurable, he should be pleased. The article has numerous inconsistencies. The author seems confused. 11. Yes, if albedo modification were to halt suddenly, the rate of temperature change would increase. But the point he misses is that it would be from a much lower initial baseline than if there had been no intervention. Temperature would take significant time to get to the level it would have been without intervention. This would buy us some valuable time, and hopefully avoid reaching various positive feedback tipping points. 12. Saltwater spray would of course happen over the oceans. He specifically is concerned about plants on land. Yes, some cloud might originate over the ocean, and travel over land. So his concern seems to refer to use of sulfur aerosols. The claim is just wrong. He needs to examine the absorption spectrum of chlorophyll. It is in the red and the blue wave bands. The absorption spectrum of sulfur dioxide is in the ultraviolet and infrared, i.e., it will not block the wavebands that plants require. The professor is just wrong on this point. 13. Yes, it will alter rainfall patterns. That is the beauty of it. Detailed simulations indicate that marine cloud brightening will increase rainfall in arid areas, while reducing rainfall over oceans. People and animals in arid areas would welcome more rain, whereas fish in the oceans are probably indifferent to reduced rainfall. 14. He is indeed correct that current climate models are inadequate. Dr. James Hansen is a prominent climatologist and is critical of current models too. They failed to predict the very sharp increase in solar flux, due to the reduction of sulfur in ship fuel. There has been a very sharp increase in sea surface temperature in the North Atlantic and North Pacific where there are major shipping routes, correlating with this sulfur reduction, and which cannot be entirely ascribed to the El Niño cycle. Current models seem to be insufficiently sensitive to sulfur, according to Dr. Hansen. And I think he is correct. 15. Correct. This is one statement that he is indeed correct about. 16. Possibly but probably not. We should not second-guess human psychology. Solar geoengineering may in fact give people more incentive to deploy renewable energy if they think there is a chance of a positive future. People who feel there is no hope for their future have a tendency to just give up and stagnate. People with a sense of hope tend to have a sense of purpose and action. 17. People who think that scientific research should not be permitted are of the same mindset as the Pope who put Galileo into house arrest 4 centuries ago. The Pope did not like the idea that the Earth is but one of several planets orbiting the Sun, and not in fact the center of the universe. We have to be bold, and allow scientific and technological progress. Not be hidebound by ancient dogma. Just because someone does not like a particular idea, does not give them the right to excommunicate those who want to scientifically research that idea. See also this article, The Trouble with Geoengineers Hacking the Planet by Raymond Pierre Humbert, June 23, 2017. Chapter, A Mental Health Pandemic, Worrying About the Climate. According to a paper published in The Lancet, 45% of young people globally are so worried about climate change, that it is affecting their ability to function. They suffer despair and a sense of impending doom. Paper published by The Lancet, Climate Anxiety in Children and Young People and Their Beliefs About Government Responses to Climate Change, a Global Survey. Really, this has got to stop. It is a form of child abuse, which is likely to cripple their mental health for their whole life. How many will seek solace in excessive drinking, or drug abuse? How many will feel so hopeless, that they give up on their studies and their future career? How many will commit suicide? How many will give up on the idea of having a family? I have met a teenage girl, a friend of a teenage relative, who quite openly stated that she would never have children, in order to save the planet. Can you imagine how terribly sad this is? Who is brainwashing them? And yet, if they only knew that global temperatures can be stabilized and then gradually reduced, at relatively small cost, relatively quickly, and using technology that already exists, would they feel so much despair? No, it would surely give them hope, and a renewed sense of purpose. Solar geoengineering is a subset of climate restoration. We can do several beneficial actions simultaneously. And it does not, of course, detract from the need to get off our dependence on fossil fuels. We can also deploy river turbines, tidal turbines, and numerous other means of harvesting natural energy. We can do multiple tasks. It would help, altogether, to give young people more hope. More hope for the future of the planet, and more hope for their own future. Chapter, Closing Comments. This book is very much a work in progress. Some figures do need to be double-checked. The figures given are understood to be approximate. The climate is complex, and the input figures to the spreadsheet are quite noisy. There does need to be a concerted effort to fully understand the sensitivity of sulfur in the atmosphere relative to CO2 in the atmosphere. This requires proper scientific investigation, which sadly has been underfunded for years, seemingly for political reasons. Around 1970 is when global temperatures really started to take off. Before then, global temperatures were wobbling up and down, with the up and down shape prior to around 1930 only being reasonably explainable if natural sources of sulfur, from volcanoes, were included in the curve fitting. Between 1930 and 1970 there was a massive increase in industrialization around the world. So here is an important question: why were temperatures essentially flat from around 1930 to 1970? How about the fact that man-made sulfur emissions were more or less in balance with CO2 emissions? Largely due to coal burning, and to an extent increasing oil burning too. And natural sources hardly factor over those 4 decades, apart from a moderately large volcano in 1932, which probably largely explains the initial cool period in the early 1930s. There has been unusually little volcanic activity during those 4 decades. From around 1970 there has been a very noticeable increase of slope of the temperature curve. Why? What happened from that date? Volcanic activity was essentially flat from 1932 until 1991, and at relatively low levels, so we do need to primarily look to human activities for an explanation during this period. The big change that started around 1970 was the curbing of sulfur emissions relative to CO2 emissions. But also note well, in 1970, the tonnage of CO2 emitted was 115 times larger than the tonnage of sulfur emitted. It does seem astonishing therefore how much more sensitive the temperatures are to sulfur than to CO2. This 115 ratio figure should be regarded as a lower bound because most of the emissions were near the ground level, and sulfur is quickly washed out of the air by rain. The height of even a tall chimney is small relative to the thickness of the atmosphere. It was rational that sulfur was curbed. In high concentrations it really is harmful to human health. But the unintended consequence is a dramatic increase in temperature globally. There has been a further increase in the slope of the global temperature graph following the ban of sulfur from ship fuel since 2020. Sulfur has been masking the strength of the CO2 greenhouse effect. The masking since 1970 seems to have been missed by climatologists, perhaps because by coincidence there was a large volcanic eruption then, putting huge quantities of sulfur into the stratosphere. There is no such confusing volcanic emission since 2020. Climatologists are at last publishing papers describing the masking due to sulfur aerosols. Humanity has been conducting an experiment on the global temperature. At higher altitudes such as the stratosphere, studies have shown that sulfur is even more significant than CO2 on temperature, by a factor of an astonishing 152,000:1 ratio. Below the stratosphere the rain quickly washes out the sulfur, so it remains airborne for only a short time, hence the 115:1 ratio at low altitude. In the stratosphere there is no rain, and also little turbulence, and so the sulfur remains for much longer, and hence is more effective per ton. In other words, a relatively tiny amount of sulfur could be deployed in the stratosphere in order to counter the warming effect of all of the CO2 emitted. And there are very few people up above 60,000 feet, a handful of military jet pilots, and no trees at all. But in any case, the concentration needed at that altitude is very low. At least 2 orders of magnitude lower than is a problem for human health. So why not just get on and do it? It seems like a no-brainer really. Unfortunately, climate science research seems to have become politicized. Funding for science research is usually from the public purse, and ultimately politicians provide the direction. There is a worrisome trend that scientists with dissenting voices find their funding cut, and they are ostracized, with no ability to have their papers published. Which is fatal for their career. In some cases, they have been sacked. There is no such thing as settled science. Any scientist who claims that there is, should be denied any further research grants, because, in their opinion, there is nothing new to learn about the climate. I have received not a penny from anyone to write this book, and so I can write whatever I like. I have certainly received no funding from oil companies. I may be wrong in some details, but you should at least see the broad brush arguments. And no need to take my word for it, produce your own spreadsheet. I have adequately explained how I produced mine. See whether you come to similar conclusions. And I will be pleased to receive genuine corrections. You can tell that scientific inquiry into the climate has become politicized. Professor David Keith, at Harvard University at the time, and is now at Chicago University, prepared a very small-scale experiment involving a high-altitude balloon and small quantities of reflective particles, calcium carbonate powder, and maybe there would be further tests using sulfates. The flight was planned for June 2021, from Sweden. His experiment was prevented by a group of reindeer herders. It just seems utterly absurd that a serious scientific endeavor is blocked by a small group. Particularly given how vitally important the results of such research would be for the whole planet. Hopefully they can be persuaded that this is important for them too. Please, anyone in a position of political influence, can you bring some sanity to climate research? It cannot be held to ransom by a few activists, it is far too significant for the entire planet. Such obstruction simply delays the research, and hence delays the rollout of practical action. And meanwhile, temperatures keep rising. All actions to date, over a 50-year period, have utterly failed to halt that rise, and so it is way over time that we try something new. It is really quite urgent now. So why is it that most mainstream climate scientists seem to have gone along a false track? Why are they pinning nearly all the blame onto CO2? And why are they not making a huge effort to support the research of Professor David Keith? That pinning the blame primarily onto CO2 seems to be the case. A huge industry has grown up around decarbonizing and net zero carbon. And government funding for research on sulfur is minuscule in comparison. Yet sulfur is more significant for affecting temperature than CO2 by at least a factor of 115 times more, when the sulfur is near ground level, and 152,000 times more significant at high altitude. It is a puzzle that the role of sulfur is so downplayed. This does seem to be changing now, due to the unwitting experiment performed by the International Maritime Organization. They have mandated that sulfur be cut from ship fuel. And almost immediately, sea surface temperature has shot up. This is, at last, ringing alarm bells. That sudden temperature response does not surprise me at all. My spreadsheet also highlights the huge significance of sulfur relative to CO2. I do speculate that the reason why much of the climate community has a blind spot for sulfur is to be found in the graphs of sulfur emissions. By an unlucky coincidence, the significant drop in man-made sulfur emissions, from around 1991, more or less exactly coincided with major volcanic emissions, after a 4-decade period of little volcanic activity. And those 4 decades had no significant trend of temperature change, sulfur and CO2 emissions being more or less in balance. The atmosphere many millions of years ago, at the time that the fossil fuels were laid down, being in balance, human activity of burning those fuels, of course, then not disturbing that same sulfur to carbon balance. Thus, I speculate, from 1991 the unlucky coincidence of reducing man-made sulfur and increasing volcanic emissions, was masking just how massively significant sulfur is to global temperatures. Global temperatures continued to rise steadily, as did CO2 emissions. Naturally, there appeared to be a correlation between CO2 and temperature if all you do is to look at the CO2 graph and the temperature graph. And that correlation seemed to point the finger primarily at CO2. Particularly adding to the misconception was the flat emissions of sulfur from 1970 to 1991, while CO2 increased and so did temperature. But correlation does not imply causation. I do wonder just how many people have been fooled by this coincidence of man-made sulfur dropping just at exactly the time that natural sulfur increased. I feel like the little boy who pointed out that the emperor was wearing no clothes. I have the freedom to state what I like, with zero impact on my career, and so did that boy. Unlike the vast majority of climate scientists, who risk losing it all, if they dare to question the scientific consensus that CO2 is primarily to blame. No, the problem is not CO2 per SE. The problem is the imbalance of CO2 with sulfur. Carbon dioxide is both a problem and a blessing. The blessing far outweighs the problem. Primarily, crop yields have increased dramatically, and human starvation has at the same time declined dramatically. Thanks to CO2. Starvation is still at far too high a rate, of course, but it is heading in the right direction. If we have a humanitarian concern in our heart, we should be grateful for CO2. Temperature rise, if it is a significant concern, can relatively easily and relatively cheaply be limited by increasing the level of sulfur dioxide emitted at high altitude particularly. The fact that there is a significant depletion of sulfur in soil, and the related fact that the fossil fuels with sulfur content of several percent originated from living organisms, indicates that today there is an imbalance. Indicative that the natural long-term balance would be for a higher concentration of sulfur dioxide relative to carbon dioxide in the atmosphere and soil, than has been the case since 1970. Unless you live in a low-lying country such as the Netherlands or the Marshall Islands, really stop worrying about sea level rise. It is happening very slowly, a few millimeters per year. A rational planning process to disallow new building construction within X meters of highest tide can very easily keep pace with the slow rate of rise. And if we can rapidly seed the stratosphere with sulfur, the global temperature rise can fairly rapidly be stabilized, and hence sea level rise can be stabilized too. Fairly rapidly means within a decade or two. If you do live in a low-lying country, then please ask your government to put pressure on the international community to stop procrastinating about solar geoengineering. The principle has been long established. There should at least be trials done of its efficacy. There is no excuse for ongoing delays and dithering. Aviation will play a key role too to help the environment. Smaller aircraft for short distances may soon be electric, but longer distances need sustainable aviation fuel, SAF. Liquid fuel has a significantly higher energy density than batteries, and is much more convenient to store compared to hydrogen, and so may still be needed for aviation for many decades to come. The SAF could have a few percent hydrogen sulfide enriched, to contribute to global cooling. Modern passenger aircraft are significantly more fuel efficient per passenger mile, if you level the figures by their cruising speed, than ground transport, road vehicles and trains. The latter always have the wheels down, whereas aircraft retract them. Wheels add considerably to drag, which must be countered by expending energy. Aircraft are becoming incredibly efficient aerodynamically, with significant further improvements in the pipeline. If supersonic planes can become acceptably quiet, thus opening up far more routes, including overpopulated areas, and flying in the stratosphere too, they can contribute far more to cooling than to heating the planet. Maybe 50x or 100x more cooling than heating. Concorde was 29x more. much more so than existing subsonic passenger planes could achieve at their lower altitude. Maybe this is counterintuitive, and not what you thought you wanted to hear, but have a go at doing the maths to verify it for yourself. There are some climate scientists who argue that we must not even start to implement solar geoengineering, because once we start, we can never stop. Quote, "The main problem is once you start, and it's working, you can't stop. Like ever. And by ever I mean hundreds of years. How would you calibrate it? How would you govern it? It is a non-starter for any sustainable, responsible solution." I do understand their concern. However, I would respectfully argue that they have a false perspective. Yes, of course, all the time that CO2 is increasing, then abruptly stopping solar geoengineering would give a quick step increase in temperature rise. They are correct to point that out. But temperature would be rising from a much lower starting point than if it had not been deployed. I would argue that, at least for the next several decades, fossil fuel usage will continue anyway. This is the reality. No amount of wishful thinking will halt that. So what would you rather have? A continuously increasing temperature without solar geoengineering, or a stabilized or even reducing temperature with solar geoengineering? And maybe even reducing it by 1.5 degrees Celsius, back to pre-industrialization levels. And so if at that point it was then stopped abruptly, the temperature would begin rising again, sure, but from a much lower starting point. In other words, it would have bought us some time. By then, we would be well past peak oil, and peak gas. Maybe not past peak coal. The point is, much of the world would be running on renewable energy by then, and nuclear, maybe even nuclear fusion if you believe in miracles. And the human population would have stabilized, and be slowly reducing, thus reducing energy demand. At that time, the role for solar geoengineering would be steadily reduced too. It is an interim measure, for the next several decades. Not forever, as some climatologists who oppose it are claiming. I have also never heard them making the argument that once we start carbon capture and storage, CCS, we could never stop. Is it just as valid, or invalid, an argument to never start CCS as never start solar geoengineering? There would be a sharp temperature increase in both cases. A termination shock. Another objection is that the sulfur aerosols are harmful to health. That is true, in high concentrations. But please put out of your mind coal burning with chimneys producing huge black clouds of smoke. That is not at all what we are talking about. We are definitely not going back to that. Instead, the proposal is to add a very dilute amount of sulfur, high up in the stratosphere at 60,000 feet altitude and higher. Where nobody lives anyway. And where it does not rain. And even at that altitude the concentration will be less than 1/100 th of that permissible in the workplace for an 8-hour shift. Yes, some sulfur will gradually come down to lower altitude, where people live. But sulfur dioxide is highly soluble in water, and so will quickly be washed out of the air by rain. The concentration at ground level will be so low, that even the sensitive instruments will struggle to measure it against the background noise from vehicles, wood-burning stoves, garden bonfires, cigarette smoke, barbecues, and steam locomotives on preserved railways, etc. We need to put the atmospheric gases back into balance. Not to focus just on one particular gas. There needs to be a balance between sulfur and CO2. Nature is in a dynamic balance when left to its own devices. Human activity has tilted that balance. However, we can measure that tilt, and we have scientific and technological knowledge, and thus the ability to restore back to the state of natural balance. All that is missing is the political will to do so. Climate restoration would be good for the planet and good for humanity too. A managed, gradual transition, so minimizing starvation and warfare. Cutting CO2 too rapidly, if it was even possible, would maximize starvation and warfare. Worries about the climate are increasingly severely harming the mental health of particularly young people. They lack the mental filters that more experienced people have, who have experienced many versions of scaremongering over the years. Scaremongering is a highly effective method by which unscrupulous political and religious leaders maintain control. In the case of climate scaremongering, it has been played absolutely brilliantly by governments. They are manipulating the environmental activists to push the governments, i.e. themselves, into the direction that they wanted to go anyway, to clamp down on the freedoms to travel of most people. Part of a wider push to clamp down on freedoms generally including freedom of expression. While at the same time seeming to suppress or ignore the one thing that would have prevented any rise in global temperatures at all, solar geoengineering by sulfur emissions at high altitude and out above the oceans. Finally, a suggestion for those who are deeply concerned and agitated about carbon dioxide and global warming, to the point that it adversely affects their mental health: don't panic. We can solve this, it just needs the political will to do so and the provision of a relatively small amount of funding. The technological means to do climate restoration are already available, and are relatively inexpensive financially, and can be deployed relatively quickly. Appendix: Averting the next ice age. The next ice age will be utterly devastating for humanity. Many areas will become arid, making agriculture difficult or impossible. Much lower temperatures will mean that growing seasons will be shorter, meaning that many arable crops that we now rely upon will not be viable. Even grasslands will have a reduced productivity, and so the numbers of livestock that they can sustain will dramatically reduce. The areas where humans can comfortably live will shrink considerably. It is unlikely that Earth would sustain such a large human population as it currently is. However, the transition to the next ice age is very long relative to a human lifespan, and so there is ample time to reduce the population in a humane way, for example by use of contraceptives, rather than via starvation and warfare. The time spans of the transition is many hundreds of years, based on the slope of the graph of the previous events. Looking at the graph of temperatures from the Vostok measurements, it seems that we are about due for the next ice age. In a relatively short time span of the next few thousand years. Long relative to a human lifespan, but very short compared to the age of the Earth. An interesting question arises: can the increase in greenhouse gas emissions postpone the transition to the next ice age? Given that emissions due to human activity account for only around plus 1.5 degrees C, it seems unlikely that the next ice age can be postponed indefinitely. Even if all fossil fuels are burned, it may not be possible to achieve even a plus 3 degrees C increase in temperature. Temperature rise is relatively insensitive to CO2 increases, above a certain level, because the relationship is logarithmic. Natural processes during an ice age cool the Earth to -9 degrees Celsius, and so plus 1 degree C to plus 3 degrees C due to human activity is unlikely to have much impact. Overall -6 degrees Celsius is nearly as bad as -8 degrees Celsius. So what are we worrying about? Should we worry at all? We would have to release huge quantities of carbon from carbonaceous rocks to avert the next glaciation. There would not be enough carbon in fossil fuels to do so. And in terms of quantity, the figures are huge. The CO2 rate of release from carbonaceous rocks would have to be several times that of the rate of release currently happening from burning fossil fuels. It is nonlinear. Doubling CO2 does not produce double the temperature rise. And releasing CO2 from rocks would have to be sustained for the duration of the ice age, which is typically 80,000 years. We have been emitting CO2 from fossil fuels at a significant rate for only around a century. It is hard to comprehend the extreme measures that would be needed to avert the next ice age.